Took the ride to the end of the lane where no one ever ended up. A broken train with nobody I know.
One, two, one, two. You're getting something. Okay. Out. One, one, two. You're sending. One. Uh-uh. Wait, wait. Ada some music. Zoom. Nothing. Mute the music with me.
No, that was too close. Okay. Is it now working? Yeah, I can hear some feedback. So good morning. Thanks for coming to this fourth session of our focus meeting on the history of astronomy in South Africa during the late modern period. My name is Sarah Schechner, and I am the incoming president of the History of Astronomy Commission C3. And I look forward to seeing more of you over the next few years. I am filling in as chair this morning for Virginia Trimble, who unfortunately has been in the hospital with a serious illness and cannot be here today. So we all miss her. I have a little booklet here of abstracts for this focus meeting, and there are blank pages in the back where if you like to send a message to Virginia, you can write something there. And after the meeting, I will bring it back to the United States and send it to her so that she can feel a piece of the meeting, be our presence and our missing of her, and have that with her as a token of us here, that we were thinking of her and wishing her well. Feel free to write on any page in here if you want. And there are some extra blank pages at the back. So I will pass this around. Some of you signed it. Okay, some of you signed it yesterday, but some of you may not have been here or have, didn't have that opportunity. So I will pass this around. As soon as I get down off this podium. Disconnecting remotes here. Sorry about that. Our first speaker this morning is Christian Starkin, and he will be speaking about the hardships of the geodetic survey of South Africa from Lakai to Maclear. So without further ado, I'm going to turn it over.
I'm afraid there's a bit of overlap between several talks, but on the other side, there's also a lot of complementarity. So where it overlaps with what we did yesterday, I will go a bit faster. And we had a very good talk by Dave Laney and also by Anne Glass about the early history. The very first person to pass here was Tashar, and important thing about what he did in the first place is he did some surveying, but it was just like his drawing. The longitude of the Cape, and he did this in a very, very approximate way. This is not a really useful new result. It is something historically that happened, yes. Then here you see map of Cape Town in the days of Tashar. And when you look here, this is the jetty where the ships would arrive. This is the fort. Actually, here was the very first Dutch fort, the fort of the East India Company. This is a fortification. And these are the shoreline here, and the houses, these couple of houses, are on the street which still exists. The street is called Waterkant, is waterside. Actually, the shoreline. It's about 20 minutes inside the city because the geography has changed. And this is an interesting place, and you can still visit it. This is the garden of the United East Indian Company, where they were growing fruits and vegetables and all to supply the ships that were passing. Actually, they came here to shop, refresh. And this is the garden. The garden is very well preserved, has a lot of interesting plants and trees. Lakai, we discussed a lot yesterday, and this is the map of Cape Town of Lakai's day. this area. This area is the estuarium of the Salt River, and the Salt River estuarium is all. Then there's two rivers coming to that. Sorry, you have two rivers coming to that place, and this is the Liesbeek River, which still exists, and the Black River. And at the confluence of these two rivers is the Royal Observatory has been founded. And this is also the region. Okay, but I have only 200, but anyway. So this is the region where we okay, Lacailla's mission is very well described in a book that Ian Glass published and which I used a lot to prepare the meeting and to prepare my talk. And Lacailla's mission is described there at various points. Lacailla mapped the southern sky. He gave some southern constellations new names. He determined the distances to Venus and Mars. And he made extensive notes about the culture, local culture, and the local people. Yes, he measured the radius of the length of the 1 degree of the arc of the meridian. And here you see the sky map of Lacailla, and the ship here is the Carina and others. And here in the center, you have a new constellation, which is called Mons Mensae, which is Table Mountain. And you have seen and you have heard about the Table Mountain a couple of days ago. There was a cloud over it. They call it the Table Close of Table Mountain. And Lacailla's Table Close is here below. And this is what we call the Large Magellanic Cloud. It's a real cloud. It is there. Then there are a few other constellations, Horologium. There is Sextant over there, all new instruments, which he has just seen in the sky. This here is on the left is an instrument that he used to do his measurements, and the map on the right is a map from his book. Interesting points on the map are here. This is the baseline, which he constructed to make the triangulation, and we have to be very careful because on these two spots over on the left, this is totally wrong. This doesn't fit the geography at all. And this is also not correct. I mean, actually, this is not deep enough. It looks like the cape is here, but actually this should go deeper. And that was one of the reasons that the maps were of that quality, that so many ships had problems and ran ashore. So he measured the length of the 1 degree of the arc of meridian and then compared it to what was obtained by others. And you have here the Northern Hemisphere measures from Lapland, which were carried out by the Maupertuis. And then you had measures from France by the Cassinis. And then in Peru, there was another French expedition. And then he found here an aberration. Actually, his measurements didn't fit the place. It should be somewhere on the curve. So he was very worried about that. And what he did, he returned to the place where he had the baseline, and he started measuring the baseline all over. This was really scientific thinking. It's verifying your standards, verifying the baseline. And he came to the conclusion that the baseline was perfect. Yes. So he couldn't explain it. So now here you see the timeline for the early British colonial period at the South African Observatory, at the Royal Observatory. So it was founded in 1820, and there you have the various staff members. First of all, you have fellows, then the very short passage, I can only call it a passage of 12, 13 months by Henderson. It disappeared immediately, was followed by Maclear, and then by David Gill. These little crosses here on the line of Gill are the travels he undertook to Europe for various reasons. One of the reasons was to catch money. Another reason, of course, was the Carte du Ciel. He went to various places in Europe And historically, the difference in this 1 century between here and the very early times is the fact that traveling became so much easier. I mean, you had steam already. You had steamers to come to Cape Town. You had also railways in Europe. You had railways here. And that made it very easier going back and forth. So these people here are Smith, Piazzi Smith, we've heard about, and William Mann were the assistants of Maclear in doing the surveying. Well, there's a very famous fellow here. This is, of course, John Herschel. I've put him there in red because John Herschel was not a staff member. He was not paid by the Admiralty. He didn't need pay. He had money. He had money from he inherited a lot of money from his father's estate and from his wife's family. So he didn't need a salary. And actually, he even plainly refused all kind of support by the Admiralty. Because, of course, for the Admiralty and for military purposes, surveying was very important. So they wanted to give him money to get back information, yes, kind of spying. He said, no, thank you. He wanted to be free, independent, and he had the means to do that. So we heard yesterday that Theron Fallows and also Thomas Maclear arrived both here in Simonstown. And Theron Fallows was afraid, of course, that his instruments would get damaged if he transported them over this road here. So he decided not to do that and put them on a ship back. And the red line is the voyage that the instruments took by Theron Fallows. The black line is the line that the instruments took of Thomas Maclear. Actually, Thomas Maclear should have arrived here in Table Bay, but there was that season quite common that ships could not enter the bay because of the wind. And then they would come to Simonstown, and Maclear had to transport all his stuff to Cape Town. Theron Fallows made a comment and say that sailors are such rough hands that they would handle the instruments exactly the same way as they handle a cask of herrings. And it really happened. That's why this damage happened to the clock and to some of the instruments. Maclear initially wanted to travel together with John Herschel on the same ship, but he didn't have the financial means, so he came with another one. And he was very discouraged by the sea voyage and all the consequences. Damage to the mural circle, I have allotted to it, commented on it yesterday. Very important thing now is that Theron Fallows, he worked himself literally to death. I mean, she worked day and night. He had no team. He had only his wife who supported him. He died very early. He was buried in the grounds of the observatory. And a very important aspect of how do we know about what he did and how do we have his data? Simply because his widow, when he died, 8 weeks later, she collected all his stuff, all his notes, all the data, carried them to London, gave them to the Royal Society and to the colleagues. And this is why we know so much about the time. She was actually, in my eyes, the very first archivist in astronomy here in the Southern Hemisphere. So how did Theron choose the location of the observatory? There was not much choice, yes. I'm showing here your map. This is a map by the very first surveyor in South Africa. It's Peter Potter. He was a member of the East Indian Company. And here you see the map. Table Bay is here, and north is to the right. In those days, north was put to the right on maps. Here you see the mountain, and there the river, the estuary of the Salt River. So now I'm turning the map the way we are used to look at maps, and I compare it with the later map here. And on that map, you can see, again, this line here, these are all farms of the settlers of the East Indian Company. They were free burghers. They got for free land, and with the land, they had the obligation to cultivate fruits and vegetables for the ships that were passing. The space available to build an observatory was extremely limited. And if you see here on this left map, this is a line on the right side. Well, this curved line here actually is a hedge. They planted a hedge, really big hedge, to prevent the native peoples coming in that region. So the colony in those days was limited to that very thin piece of land between the mountain and the river just behind the Lisbeth River, and that was the end of their actually colony. This is the original plot of the purchase of the observatory grounds. And on this here you see the names of the owners of these properties. This is Mr. Mostert and also Reiniers. And Philemon Fallows complained about problems he had with Mostert and Reiniers. These were not the same guys. They were the grandsons who wanted, of course, to get money. And well, they got a lot of money, and the money was paid by the Admiralty. And finally, the observatory was established on that place. This is a map from coming from a letter from Fallows. And I also turned it upside down. I turned it with north up, more or less. And here you see where this yellow place is in between the lands of Mostert and Reiniers. This is the confluence of the two rivers who come together. And this is here, this so-called dismal swamp area. Interesting point about this map, I probably sent more than a dozen of emails to various archives in Cape Town. And in Brian Warner's book, he said in which archive he took it. The archive doesn't exist anymore. It was transferred to the National Library. I took contact with all these people. Nobody can find this map. Yes. And this is one of the points of our meeting where we focus on that, in my opinion, a lot has to be done on archiving and in opening the archives in the, let's say, for the modern digital access. So here you see the Lisbeth River in one of the paintings. I think it's from Thomas Bowler. There was no bridge. There was a road to Cape Town, no bridge. So people would wade through the river on foot. They had these little wooden bridge for passengers, but you could not cross the river with any ox wagons or nothing else. And this is here a very nice painting. Again, you have the mountain top here, the observatory with the front, and then the two domes on it, and in the middle, the turret. All these have disappeared. And here you see an ox wagon and a span of oxen. And if I look very well, the ox wagon seems to be loaded with casks of South African wine, and that's the picture. Another interesting aspect of social life in those days is to look at how people sailed to Cape Town and whom they brought. So Fallows had his wife and a child, and he brought on the ship his maid, Sarah Bootle, and also an assistant. Yes. First time I saw this, it looked a bit strange, but Herschel did the same. He had a nursemaid for his kids, and he had an assistant and a technician. And Herschel and the family were in the top cabins in the ship, I would say in business class. Yes. And the nursemaid also, but the assistants and the technicians were down in tourist class, I would say. If you look to MacLear, it's exactly the same pattern. Yes, they bring governors, they bring a nurse, and this is something we should really understand in the Victorian society, especially in the United Kingdom. There was a shortage of men, there was a surplus of women, And why? Because a lot of men disappeared to the colonies, and the women would stay behind. And being a single woman in those days, you had only two options. Either you go to a convent or you get married. But if there are not enough men to marry, and you could only marry men, you had to go to the colony. And it's a kind of blind date. There were even companies who organized the trip and who offered to women a trip, including a list of eligible men. And when they arrived here, of course, disappointment was very often more frequent the case than others. I call it Team McLear, sorry, but the team, as I said, is one person, and he tried to do everything, and these are all the tasks he had to take. Measure, the last one was the biggest, measure a geodetic arc of the meridian. That means measuring the baseline and doing the triangulation of the colony. Not just the region around Cape Town. He had to verify Lacaille first, and second, he had to extend as far north as he could ever get. So baselines, I've pointed it out already, have to be measured very, very carefully and very accurately. It's a matter of inches on the distance. He did various baselines. There is one on the Grand Parade, where you see this picture here, the Grand Parade, the place you can see, but there is nothing left from those days. There is now a marketplace. It is a rather filthy region. And this was done, this is a short baseline for the only purpose so that surveyors could go and calibrate their own chains. Because and this will be the next talk, the surveying profession started shortly after that, and surveyors had no schooling and had no good tools. So they had to calibrate the chains. Then he had the arc of Lacaille to remeasure. Then there was a baseline in Klipfontein. Oh yeah, by the way, here this is a cannon. That cannon was, there were two cannons put vertically in the ground on both sides of the baseline on the parade, and just to make sure that nobody would change these marks. They were just sunk in the ground. And now if you go to Strand Street, and there is a shopping center there, I forgot the name, but it's one of the tallest buildings there. And if you go in the basement, you will see the remnants of Cape Town water basin, where the East Indian Company was collecting water as a reservoir. And this cannon was on that place and is still displayed, yes. So you can imagine, okay. Then there's a baseline at Klipfontein. This is in the north, where Lacaille was. And you see the baseline here and the triangle. And then to the right of it, you have the observatory of Lacaille. The problem with verifying anything from the past in this surveying is that you do not easily find the exact location back. Things have changed. There's always some guesswork, so you can do very accurate, actually very precise copy of the measurements. And it is inaccurate because you may just make a mistake and measure from the wrong place, wrong building, wrong platform. So assistants for the baseline are there William Mann and Piazzi Smith. Piazzi Smith is the person who made the painting, which was on the meeting poster, the comet, and she was a very, very good artist. And also John Herschel was a very good artist. They took the time to make really, truly nice and accurate pictures of this. So the baseline is measured with rods of about 2 meters, yes. And McLear was very sure that he called Lacaille the old man, that the old man had made a mistake. And this is what he really wanted to do. He said either the old man made a mistake or there's a big hole in the earth on that place, yes. So when he did the measurements and then he did the reductions, he found out that the old man had not made a mistake, that there was something else, yes. So he then continued as far as possible to the north. And this is about the hole in the earth. I mean, George Everest was doing the survey of India, and he took also a very long meridian, actually the longest ever meridian chain. And Everest was feeling bad, he was ill, and when you were too tired in those days, you would get a couple of months leave and spend the time here at the Cape Colony just to restore your forces and go back to, to your place. And Everest came here and he said that if Lakaya's baseline was correct, then the difference in the length of the meridian is caused by the attraction of nearby mountains and by the underground. And John Herschel really checked the geology of the cave, and he came to the conclusion that what you see, but mainly what you don't see, is very dense granite boulders all over. And that causes part of a deflection of gravity because you need the plumb line. If you remember the sextant of Lacaille, the plumb line is hanging, and you read on the divided circle the position of the plumb line. So the direction of the vertical direction is a very important point. It doesn't explain everything, yes. What you see here is the difference between, again, the model and the reality, the difference between the geowidth that Lacaille wanted to see and everyone believed because Newton had explained it, and the reality, which is gravimetric measurement. And here you have very quickly the difference between geowidth and the real. Okay. Very interesting point. She built a beacon, a most expensive experiment, and the beacon is here. This is a vintage photograph of the 1970s. This was taken before the Olympic Stadium was built, evidently. And the beacon is on the far side here of Table Mountain, and you can easily take the cable car and go there and walk over. Be careful, don't go there when the tablecloth is on because it's very unpleasant then. The point is that this was so expensive because they had to bring all these rocks to build this actually passive beacon, because the beacon cannot be seen from the Royal Observatory because the mountain in between, but the beacon serves to connect that point with the far point on Cape Point over there, and then connect it to the east to Cape Agulhas to expand the surveying. So if you look at the local situation, you have here modern Cape Town, and the very important points are here SAAO, Lacaille's Observatory, which is here in the city, and then you have the King's Block House. This is a kind of fortification, and Devil's Peak, and here the Maclear Beacon on, yeah, this, I'm going to skip this one. And then they started to triangulate this, and the first thing to do here is a baseline near the observatory. So here you see the Black River and the Lisbech River, but this is a modern picture, of course, this is Google Earth. And in the old days, the Lisbech River was running like here. They canalized it and changed it, but anyway, the Royal Observatory is there. And then they built this triangulation. So you see a couple of triangles here between Lacaille's place. So this was next to the seaside, next to the shore. And we are sitting here. In those days, it was plain water, the harbor. These two triangles. And then John Herschel came, and he wanted a little triangulation for himself of his own property with his own telescope. And they did this. There was no reason to do that, but they did. And Herschel's property is over here. And this is here one of the rocks that they used as a triangulation point. This is here largest. And now you can see the triangles that they built to determine the location of his large telescope. As you can see, the geometry of the triangles is entirely different of the geometry of these. Triangles should be somehow nearly isosceles and not this kind of skew situations. This is the place where his telescope was standing, and you can, with the triangulation, determine the place very exactly on the Google Map place. Below the obelisk is a box. It's a time capsule. There is some coins inside, some instruments, some documents. And it's a place, it's not open for the public, it's a private school, but you can get in if you happen to meet a friendly director. And she let me in. And I took a photograph, the one on the left I took 12 years ago, from the place of the obelisk. And here I compare it with John Herschel's, very well known. And okay, the trees and plants are different, there's a lawn there, and so on. But if you look at the skyline, it's just one is a copy of the other. It's very impressive. It was also very nice weather that day, very impressive similarity. And this is a very important stone, and I will come back to that in the last communication today. It's called the Weinberg stone. And this is from a paper by Jennifer Whittle and her colleague. Stone is about 4 meters high. It's about 20 tons, I calculated. It's pure granite. There's also granite underground, which we cannot see. And Herschel climbed the stone because in his letter he says, I took angles from the top at the risk of my neck from the top of Weinberg stone. Yes. And now you have to know that all the other triangulations were done with a top class theodolite, which is a heavy instrument. Yes. To do that from this little base, which had barely 5 meter diameter, he had to use a lighter theodolite, so handheld theodolite. And this is one of the reasons why some of his angles are not very perfect, and he knew it. He says, you cannot, probably that's the reason, yes. So this is Herschel's house in those days, and interesting point is just a detail here. If you look at the mountain, in those days it was not Devil's Peak, it was called Windberg, Wind Mountain. And I found a very old picture from an atlas where the name is yet different, and it's called in Dutch, it's Duivenkop, yes, and Duiven is dove, it's dove head. But the difference in Dutch between dove or pigeon and devil is so little that they use Devil's Peak. And now people try to return to the old name, but for tourism, this won't work. People prefer a devil than the symbol for peace. So again, in his letters is very important social information. He says that, well, it's very nice once you are traveling. He was going on horseback day after day, everywhere in daytime. He would observe surroundings. At night, he would look at the sky. And once you descend, he said, it's really, you go from purgatory into paradise. And then comes a very important statement to it. Yes. And I want you to read this. He says, everything here delights us as it did at first, except perhaps a tyrannical spirit which colonies are apt to engender among their inhabitants towards the natives. So, Theon follows. Thomas McClure, John Herschel was making these kind of comments all the time. They were not just working for a commercial company that was to pull profit from that. So I'm going quickly now. This is McClear's survey. You see here the blue dots and the red dot are McClear's results. And here on the right, you see that on this more modern map, 2 of his stations are in the water. So even that map was not good enough. If I overplot this on Google Maps, all of McClear's stations, this is exactly the same Excel file, left and right, are just correct, yes. So, and this is about the end. He got a very important visitor, and it was Charles Darwin, who came along with the bigger ship, together with the captain, Robert Fitzroy, to discuss with John Herschel about things they were commonly interested in. And this was geology, first of all, and second, it was evolution. And they had long discussions about this. And people who work in evolution very often quote a sentence which is called the mystery of life. And literally, I quote, the mystery of mysteries. And nobody remembers where it comes from. Actually, it's from Herschel. John Herschel, the astronomer, was so well known in theory of evolution that his statement is still surviving. Thank you. We can move on. Okay.
Okay, I think we're just. I think we're out of time for questions right now, but we may gain some time during the course of this session, and we can come back to questions to Chris. Our next speaker is, I believe, going to be coming in by Zoom. So if we can pull him up, this is Mulemwa Akumbelwa on the influence of astronomy on the establishment of early scholarship and surveying education in South Africa. So I see he's on Zoom. So if we can patch him in. Sorry for the delay here. This was unexpected.
My apologies. Am I on?
So Mulemwa, we need you to share screen with your PowerPoint if you can. We have it here, but so we can.
Okay. I am sharing, but I'll share again.
Okay, we can see you now. I think we're good. So I will turn it over to you.
All right. Thank you very much. My apologies. We had a power outage and it affected the Wi-Fi connection. However, my name is Mulemwa Akumbelwa. I'm presenting a presentation we put together with my colleagues, Professor Koos Landman and Mr. Angus Forbes, whom we work with together here at University of KwaZulu-Natal. The paper basically will look at, the presentation will look at the development of surveying and how astronomy had an influence there. So in terms of what I intend to present, I'll look at the early period, that is from the 17th to the 18th century, and then the contribution of South African ethnicities to survey education, and then the influence of the early astronomers on survey education in South Africa, and the early education of surveyors in South Africa, followed by the demise of survey departments at some universities within here in South Africa, and then the present and what the future holds. So in terms of the early period, the first surveyors in South Africa had no formal survey education, the first recorded ones. And the first recorded surveyor is Peter Potter, who arrived in 1655 and was appointed as the first sworn land surveyor by the Dutch East India Company. So this is again affirmed by the first diagram, which represented a portion of land that was drawn by Peter Potter. Now, Potter was not a land surveyor by training, but he was literate, numerate, and artistic. And so he gained experience at chart making. But through his work, within the Cape at the time, he is recognized as someone who more or less spearheaded the development of land surveying as a profession in South Africa. And his methods of recording land rights are still in use here in South Africa. After Porter left office as the land surveyor, a number of surveyors succeeded him. And the thing to note here is that most of them were selected for their general abilities rather than for their special knowledge in land measurement. So that was a very interesting aspect. Now, as the settlers came in, they obviously interacted with the locals, and so they needed to understand how the locals understood their own land ownership. Now, African communal tenure is a complex and varied, and so the measure of ignorance of that by the settlers, well, has been well articulated. So the locals did have a notion of land ownership, but they didn't have a system of surveying or recording that ownership. And so when the early formal education of surveying started in South Africa, this was not something that was included. This was omitted from that process. Now, why have I mentioned these early periods? This is to illustrate the fact that there was measurement of land taking place, but that those people who were doing that were not really trained to do that formally. Now, the first people who really were formally trained and had an impact on surveying are the three astronomers, that is De La Caille, Thomas Maclear, and Sir David Gill. So these three have had so much impact on surveying education and its education here in South Africa. I'll look at each of them and what they did. The first one is Abbe De La Caille. He was a French scientist and mathematician, and he was sent to the Cape to catalog the southern stars by celestial coordinates, covering the period 1751 to 1753. When he completed his work, he then made something that has made a significant contribution to geodesy in South Africa. He is the one who measured the meridian arc in the southern hemisphere where no arc had previously been measured. So from there, the work that he did, he was responsible in part for initiating what was to become the basis of the South African trigonometrical system. So his work had had some issue with it, which needed to be clarified. And the person who was then sent to verify that meridian arc was Sir Thomas Maclear. So he came in to perform a verificatory meridian arc, and this was recommended by Sir George Everest. So he conducted that verification, and having done that, he extended his triangulation northwards and eastwards. This is significant because these points to which he extended his triangulation would serve as very important points in the future South African grid network, even for geodetic purposes. So those points became the foundation for subsequent geodetic operations and survey work. So in a way, he is then considered to be the pioneer of the survey system in South Africa. This is something that is recognized by the National Geospatial Center here in South Africa. Now, after him came Sir David Gill in 1879. So he persuaded the British authorities that a geodetic triangulation was necessary for all future surveying and mapping of the country. So the work that he did, he along the 30th arc of meridian, basically would act as a backbone for all surveying and mapping in Southern Africa, because the geodetic triangulation extended up north inland. It extended inland and up north, and that formed the backbone for all surveying and mapping that has been used here in South Africa, and for the purpose of calculating the figure of the Earth as well. So these three, Lacaille, David Gill, and Thomas Maclear, did serve a very, very important foundation for geodetic surveying, which is essentially which became part of the education system that, or it became part of the education in the future surveying curricula that has been used. Now, the national triangulation is based primarily on the work of Sir David Gill, as I have mentioned, and their contribution is quite immense to the present survey system that is being used. So indirectly through their work, they have made very, very important contributions to the surveying syllabi in South African universities. Everyone who studies here has to learn about triangulation and the history of that triangulation, and you cannot talk about the triangulation whether you're looking at coordinate systems or geodesy without taking cognizance of the work that they did. So now, in terms of the early education, there were disputes that arose regarding positions of boundary beacons and incorrect diagrams that represented them. So in 1834, the Cape Colony government decreed that land surveyors would only be allowed to practice after completing a qualifying examination set up by the Surveyor General. So from 1834, examinations were introduced for people who wished to qualify for the right to practice as land surveyors. Now, we have to note here that this was specifically an assessment of competence and not formal education. Regarding the formal education, this dates back to 1878, when at the Diocesan College in Cape Town, there was established a course in surveying. And then also in 1882, there is a record of showing students who studying surveying at Grahamstown at St. Andrew's College. So St. Andrew's College was then later to become Rhodes University College. So they offered a formal surveying qualification until 1958, when it closed. So this is a picture of some of the students. This was taken around 1882, showing the 5 students. You can see the surveying equipment in their hands, and also behind them there. Now, in 1881, Stellenbosch College was founded, and it started offering classes in surveying. However, it didn't result in a recognized qualification. And Stellenbosch College then became Victoria College, and a 2-year diploma course commenced in 1893. And after Victoria College became Stellenbosch University in 1918, for some reason, the surveying course was no longer offered a couple of years after it became a university. Now, one of the oldest recognized university, which would then later offer a bachelor's degree, is the University of Cape Town. So it was initially founded as a school for boys, providing tertiary education, but then women were later on admitted into the college, and it was formally established as a university in 1918 and moved to its present site in 1928. Now, the first director of trigonometric surveys, more or less the Surveyor General equivalent, did play an important role in the establishment of that surveying degree at University of Cape Town. And the curricula at that time did bear a resemblance to the curricula which were offered in Europe at that time. So the first 4-year classes did commence in 1929, and also at the same time at the University of Witwatersrand in Johannesburg, another Bachelor of Science class also started. The initial curricula did place great emphasis on the measurement science, that is mathematics and physics, in addition to cadastral-oriented courses. The curriculum did continue with the new modules added, and this was to accommodate new technology and also its impact on the work of the surveyor, the classical, what you might call the classical land surveyor. However, even with that, South Africa had 5 departments across the country which were offering Bachelor of Science degrees. And with those degrees, 3 of them unfortunately have closed, and only 2 have remained. That is the one offered at University of Cape Town and the one offered here where I work at University of Natal. But the one at University of Pretoria, University of Witwatersrand, and University of Fort Hare, those unfortunately were discontinued. Now, in terms of the successes, we can see that astronomy has had quite an influence in that the introduction of the technique of triangulation, which required the use of suitable angle measuring devices to be able to measure meridian arcs, were very important. This formed something that was essential to the curriculum. And the challenges which have led to some of the departments closing could be maybe the cost of equipment, or they were unable to keep up with that, and also restructuring of courses within the universities. But in terms of the future, the current and the future, though technology has changed, the principles of astronomy are still at the core of positioning methods, because we use a geocentric Earth-centered coordinate system, but it has to be referenced using astronomical methods. Even the satellites which are positioned, the GPS satellites, Galileo, GLONASS or Beidou, all of them also have, we also have to have almanacs for them in terms of the information. So the principles are still there, though the technology may have changed, but the principles are still there, and they will continue to be used going into the future, regardless of how the technology changes. And with that, I'd like to conclude that astronomy has had a very significant impact in terms of surveying, and it will continue to have a significant impact as long as we are looking to position ourselves here on Earth. Thank you very much.
We have time for a couple of questions from the audience or the online community. Do we have any questions here in the room?
Just looking up a reference, and apparently clears northern sea. Anyway, the reference I looked up said that McClear's northernmost point was 30 kilometers north of Joyfontein. How that corresponded with what you said. I would ask him if he can hear it the way you saw it. You know, much engineering mind of it.
The question. I'm sorry, we're having a little microphone trouble here in the room. The question, I hope you can hear us now.
I can hear you, but I could not hear the question.
Well, the question was about the site. What was the site? Okay, the northernmost point that McClare reached, according to Brian Warner, was the northernmost point. I'm sorry, can you repeat the 30 kilometers north of Joyfontein? Yeah, can you please come up here? I can't fully hear you. Just a patience, we're going to get the question to you.
Okay.
Whether the question is worth this much effort is another matter, but all I was saying was that in the description I have here of McClear's survey, he extended it to a point 25 miles northeast of Royfontein in an area which was completely free of mountains. I just wondered if that corresponded with the information that you have.
I'm not sure about that. I'm not sure about that particular information, so I'm unable to answer that one. But I see there's a question online here, which says, are there steps to revise land surveying in communal areas? So at the moment, Yes, there are steps that are being taken. In fact, the land tenure system in communal areas is a critical part of is an essential part of the curriculum now for land surveyors, and so that is something that steps have been taken to address that aspect. Yes, thank you.
I think we should thank our speaker because we need to move on, and you can communicate him more through chat. Thank you very much. And our next speaker will also be online through Zoom, and this is Auke Slotgraaf, who will be talking about rescue archiving, lessons learned at Boyden Observatory and elsewhere in South Africa. So we'll need our last speaker to stop his share, and we'll bring up Auke in a moment.
Thank you, Sarah.
Auke, I think you need to share screen if you have it.
Could you ask the people just to make my camera maximum? You can see my presentation.
We're just a second. They're still working on the connectivity here in the room. So we don't see your presentation yet.
Do you see my camera?
No,
Oh, my Zoom camera is
right.
on.
You need to share screen.
Okay. Could you perhaps ask them just to maximize my camera view, this one?
They're trying.
Great.
Okay, now we're here. We see you. We see your screen.
Awesome.
Great. Take
Thank
it
you,
away.
Sarah. Thank you, Sarah. And as we learned on Tuesday, I wear mask. So, you know, a prominent piece of advice about public speaking I was given years ago is to never start a talk with an apology. So I'd like to offer several apologies, one of which is that I apologize for ignoring this advice. Another one is that probably some of what I'm going to say is not even intended really for this audience, by which I mean, I think we all here in this space now are pretty much engaged in history. We believe things are worth remembering, and it's my hope that some of this discussion will reach people who are not so committed as we are. So I apologize to some of you if I'm bringing coals to Newcastle. My final apology, at least for now, is that I'll be talking about astronomy, but I'm not an astronomer. And I'll be saying things about archiving, but I'm not an archivist, which means I might just offend absolutely everyone. So with all that out of the way, hello, my name is Auke, and it's a great honor and a pleasure to be here. My formal background is in computer science and clinical psychology, and I work in agent-based modeling of behavior. I live in Cape Town, and I visited the SAO often, the first time being in 1981 as a school kid. And I think it's fantastic that the general riffraff of the public was allowed access to such a wonderful place. And I think a lot of what we all here are talking about is really related to access. Speaking of access, in probably the most highly cited work about the Milky Way, the author, Douglas Adams, described how a certain document was available for public comment at the local planning office on Office in Tauri. And this document was guarded by a door, and the sign on the door said, "Beware the leopard." If you remember Dave Laney's talk yesterday about the leopard. Now, I'm worried not about the leopard or in general things that bar access, but I'm worried that the entire filing cabinet may just simply be tossed out one day. This is why I'm framing this talk as rescue archiving. And you know, to be honest, as a very naive person, things frequently surprise me. I see important people doing important things, and then I'm shocked by their apparent disregard for the laws of physics. Because as far as I know, time travel isn't possible. Yet I often see people, clever people, treating the past as if it was either irrelevant or if it was in some way a given resource. This attitude struck me as particularly curious when I first encountered it in astronomy, because I thought naively that astronomy is a practical science that particularly values observations made over a long temporal baseline. And data gathered in the past can never be gathered again. I mean, in psychology, for instance, we use longitudinal studies to observe changes in behavior over time in the search for a causal relationship or some kind of long-term effect. And the past is in some way related to our memory. And often I'm also shocked by how terrible my own memory is. For example, at the SAO are a number of fine old timepieces. And I'd like to just insert here that you should please visit the SAO Museum. It's lovingly curated by Professor Ian Glass. There's some awesome things to see there. Now, several timepieces have Roman numerals on their dials. And I definitely remember these as going, 1 and then 2 1s and then 3 1s and then IV and then V and so on. But of course, this isn't the case. Most of clocks and watches in the world that use these Roman numerals, they look like this. So there's that suspicious looking 4, which is probably not what I think I remember from seeing on clocks. But then, of course, we're dealing with people, and there's always somebody who just has to be different. So here's a reflow clock. This is actually the one that is the timepiece for the Franklin Adams telescope up at Topisuk, which Professor Carruthers will be telling us more about this afternoon. So you can see here they've decided to use a more modern IV style. So this memory glitch tells me something about our relationship with the past. And it also makes me think that it's almost as if we humans have some kind of tunnel vision, or more apropos, this audience, a worldview of a very specific narrow lens. It's like we're on some space-time diagram, we've got a light cone, and we truly believe that nothing outside of this exists. It's almost as if we lack context. So this and other factors come together to bring about what I think of as a state of neglect. So what do we do about it? I don't know. I'm not a magician, at least not a real one. So all I can share with you is my advice on what to do when the baby's already been thrown out with the bathwater and you're now frantically scrambling to close that barn door before the horse gets out too. And I'd like to attempt to do this by answering just the fundamental questions. The first of which, why do we do this? I think some of that's been covered above. I think the past is important. It actually happened, but we don't understand it. And as we rush headlong into the future, we can surely use that as a guideline for this just-in-time building of the railway track that we'd like to stay on. For me, the answer is simpler. There are no time machines. Doctor Who's TARDIS is busy elsewhere. So this is it. Find your compelling reason. And whatever that is, turn that into sort of a cult-like mantra. Why are we doing this? Because trust me, you're going to have to gird your loins. As far as the what are we doing when we are doing this rescue archiving is concerned, I sort of think of those in terms of 3 buckets: caring, cataloging, and communicating. Caring is about working with the physical items, the real thing, the thing you have to conserve, fixing damage, slowing down decay, attempting to ensure long-term stability. This also includes reformatting, where you translate the physical object into a digital surrogate, typically by scanning. Cataloging, that involves gaining intellectual control over the material, collecting basic info, enhancing it with descriptive metadata, and then importantly, organizing that data. And even if we've got these first 2 perfectly done and it's just everything is hunky-dory, that I don't think is sufficient or even a good enough reason. I think a third important pillar is communicating about sharing this material that you have preserved. It's about access. It will involve some form of controlled access, which in itself is a problematic topic. And I think they're saying that these 3 pillars do not follow each other in a strictly linear fashion. There will be a lot of iteration and back and forth and going on. And you can think, for example, as your collection grows, you'll find yourself doing different sub-goals, sometimes all at the same time. Talking about that collection, maybe just a quick word about the scope or what material do you archive? I sort of think of this as orphan material, by which I mean roughly the creator of this material isn't around anymore. In such a case, what typically happens is the material just sort of hangs about, it becomes forgotten, it becomes somebody else's problem, and then eventually it's lost in space and time and meaning. That's to steal a line from the Rocky Horror Picture Show. This typically happens when there are no records management systems in place, or when, even if there are clear policies, they are simply not being followed. So instead, archiving to a large extent is about preparing for failure. It's about having archival policies in place and also paying attention to digital preservation, but we'll talk more about that later. Now, the interesting questions: when do we do this? Well, this is 2024, and I was toying with the idea of giving this whole talk using memes and TikTok dances and so on, because that seems to be trending the way that most people are consuming their news and information nowadays. I knew if I did this that Ian would never talk to me ever again. So briefly, my answer for when do we do it is now. I mean, this is rescue, right? If you delegate this to a committee, then poor Timmy is going to drown in that well long before you've scheduled your third Zoom meeting across six time zones. Now, I'm not saying that you must drop everything and rush to your rescue site and start digging in. Although, having said that, I have been in a rescue situation where this is literally what happened. I was struck by flying pieces of masonry as the building that we were in was being wrecked as we were carrying stuff out. And yet, things could get worse. For instance, consider the ongoing Russian terrorist attack on Ukraine. Several observatories have been vandalized. As of last week, UNESCO confirmed that 432 cultural sites have been damaged. And this includes the large-scale theft of documents from the state archives of the Kherson Oblast. More about that later. But given that you're not being invaded, then I would say the when starts now, and it starts with learning. Given the constraints we're under, we can't all go off and get a degree in archiving. And we don't have the money to hire the A-team, the archivist team. But you also don't need to go in blind, nor do you need to reinvent the wheel. So start now by learning from standards and best practices, the whole shoulders of giants things. Where do we do it? Anywhere astronomy is done. It seems like a no-brainer, the observatory, but remember there are other places too. There are institutions, there are organizations. I think an obvious example here would be the IAU and AFAS. And then there's, of course, private collections, the works of individuals. In our case, we've been helping out at Boyden Observatory in Bloemfontein, at the SAO in Cape Town. We're also working with several individual collections, which brings us to probably three of the most interesting questions. Who does this? Well, it's people. And in our case, in the case of rescue archiving, it probably really means volunteers, so not paid professionals. You're going to need some kind of critical mass to get things going and to keep the momentum. In my experience, these are the categories of people that you should be looking for. I think you need to identify a champion in your team. This is some passionate cheerleader who will do this come hell or high water. You need a guru. This is a person with specialist knowledge of the place that will give you an insider's point of view. Then it's super useful if you can identify a boffin. That's some local person in your country, in your city even better, but in your country who knows the local archiving scene and can give you localized, contextualized advice. Of course, you need volunteers. These can be delegated very important tasks that they can do. And then if there's money involved, because sometimes these things do cost money, you might want to consider getting somebody on board who is good with fundraising. I'm terrible at that. I can't swim. I've got lots of bad things, but getting money is not one of my strong points. So if you can find somebody who knows how to get that, go for it. And you might also consider some kind of legal entity, a non-profit organization or an NGO, whatever it's called in the different countries, mainly because sometimes grants and donations, the organizations that do that give grants and things find it easier to support an organization rather than just to EFT a bunch of money into some random bloke's bank account. Two topics of great interest. How do we do this archiving and with what do we do it? Now, the how has got a bit of a built-in tension, I think, between following standards and best practices on the one hand, and then having sort of an attitude. I hope you can sort of hear the capital letter there, some attitude. And by attitude, I just mean something along the line of these, these cliches. I'm not sure what it means that these quotes all come from military leaders. I'm not proposing a revolution. I'm just pointing out that the greater the threat, the greater the need for determined expediency. Learn as much as you can, but there's no need to learn more. Fortunately, archival science has been around a long time. Several standards are freely available from large national organizations. I'm thinking, for example, of the American NARA, not to be confused with the NRA. And in the UK, there's the TNA, the National Archives. There are also special interest groups. From these documents, you learn the fundamental concepts and their implications. As to the very specific question, what standard would I recommend? Controversially, I'm inclined to say that they're much of a muchness. They're different ways of slicing the pie. And to critically evaluate them is going to require several PhD dissertations. If you hold a gun to my head, I would vote for the IAU standard. After you do your evaluation, choose one and stick to it, you'll be golden. From studying various of these documents, here are a few things I learned that I'd like to share that are, I think, different. As a non-archivist coming from computer science, it was striking to me that archivists use a hierarchy of just 4 levels to organize their data. It goes collection, series, file, and item. That's it. An item is the physical thing. It's the smallest unit. It's what you can hold in your hands. And the collection is the whole shebang. Furthermore, each of these levels have the same descriptive fields, making for a very elegant data structure. Typical fields are accession number, hierarchical level, item size, title. Archivists also distinguish between indexing and cataloging. This might mean something else to programmers today. Probably one of the most interesting things was to get my head around what an archive is not. For instance, an archive is not a library. I used to think it was. A library has lots of people wandering in and out, and its material is neatly sorted, alphabetically or by the Dewey system or whatever. And these are 2 aspects that to archivists are an absolute horror. For one, you don't want people walking around touching your precious with their dirty hands, breathing garlic all over your scrolls, messing up the relative humidity, their body heat altering the ambient temperature, or heaven forbid, putting something in the wrong place. Similarly, an archival material is not arranged by alphabet or by the Dewey system. That doesn't mean it's chaos, however. Archivists follow a principle known as respect d'enfant, which means respect the collection. That means it's your job to maintain and preserve the original order and the context of the material that you're working with as you find it. Say, for example, you've been handed the important material that belonged to Bob, the famous astronomer. You're given a tatty old folder and scribbled on the front, maybe in blood, something is important. And inside you find some receipts, 5 copies of the same bank statement, say a couple of abstracts and a letter to his mom. So what you don't do is you don't sort this. You don't say, oh, I see, I can sort this chronologically. I can put these things, take all the papers, shuffle them about, get them in nice date order, and then, okay, here's a pile without dates. Let's just stick them at the back. Nobody's going to know. You also don't sort the stuff thematically. Oh, look, financial statements. We can put the receipts and the bank statements in this pile, and we'll find probably more, and we can add them. And then, but here's the letter to his mom. Now, is that correspondence? Is that personal? What is that? I don't know. We'll sort it out later. That's what you don't do, because you are imposing your context, your order on the material. And the point is, it's not your stuff. There's meaning in the order. You might not know what that meaning is, but that doesn't mean that there is not meaning, just because at the moment you cannot see it while you're working with the material. What about that tatty old folder? these questions depend on, do you keep that folder with the name written on? Does that, if you remove it, does that impact the context of the material? Does it damage your collection? If you have this item in there, is it some way chemically going to be bad over time? General rule, if you can control that item, then get rid of it if it is problematic. What that means is, if you think that this object, this folder is degrading too much, you can describe it, measure it, and then you include that in your description in the catalog, and then you discard that that problematic item. The same is true for duplicates. 5 bank statements, identical copies. Do you keep duplicates? General answer is no. Keep one, make a note of the others, discard the others. I find it difficult to discard duplicates. I normally keep them in like a secret box. And that there are pros and cons to that. So if an archive is not a library, it's not a museum, what is it then? And I think the best way to think of it is a maximum security prison. There's a strict warden patrolling the corridors. And in fact, I think when you are cataloging the collection, you must think of yourself as a crime scene detective. If that's your mindset, you're on the right path. When you're faced with something for the first time, take in a general view, write down a high-level description, take photos with your cell phone, then go and enhance your general impression of the thing by examining material in closer detail. Take notes, take photos of your notes. Make sure your phone has the correct date and time. This can be immensely helpful later when you want to track changes. So don't move stuff about. Start the initial ordering, and number everything, write everything down, and take cell phone photos of everything you can. There's an example of at 2 observatories where numbering is just the way to go. Best practices, interesting problem. Some of the archival people are highly technical. You can get lost in the metamorphose paradigm, which is for high-end users. I would suggest look at FADGI. And if you're only going to read one book this summer, then make sure it is this one, which is remote captured by Jodie Butterworth and her colleagues from the British Library. This is their primary source for the Endangered Archives project. Well worth studying, chock and block full of useful information. Secondly, best practices, that's about working with a physical thing. And here there's also a lot of information about what one can do, where you realize that archivists use special things. They don't use pens and pencils like we normally do, because they're concerned about long-term conditions. What's the chemistry of this thing going to be doing over time? These things can be difficult to find locally, and this is where that boffin I mentioned earlier, the domain expert, comes in useful. They probably work with this kind of material day to day, and from them you can probably learn where to find it. One thing I found fascinating is that some of this truly archival equipment can actually be bought at an art supply shop. On the right there, we have a pencil, which is pure graphite. So there's no wood involved, so there's no lignin, a bad chemical. There are markers with archival ink, and there's special pens that write on anything, glass, metal, funny putty, probably on a bowl of mercury if you really wanted to. So your local guru and your art supply store will go a long way. You can, of course, buy everything online. That's just the way the world is today. And I would lastly then just want to leave you with one final free resource that you can find on our website. It's a crash course about everything to do from working with paper to archival theory, digitization, and digital preservation. The lecture notes and the videos are there, and it was amazingly sponsored by the British Library's Endangered Archives program, presented at the observatory. At the moment, we're in the process of moving the videos over to YouTube, so please be patient during the switchover. And with that, it's almost time for lunch. So thank you for your attention.
Thank you, Aka. Do we have questions from the room for our speaker? I'll just make a comment, which is that standards and best practices and attitude, sometimes the attitude is in contradiction with the best practices. And that's where I think sometimes people doing rescue archiving can get themselves into trouble because they say, oh, we have to do something now, and this is the right thing to do, and we're going to go full steam ahead without taking a moment to look at the best practices. I've seen a number of cases where uh, collections have been irrevocably damaged by a rush to do something and with the best intentions by the individuals. It's not like they're out to destroy their records, but they don't realize that what they're doing is irreversible and there were more measured ways perhaps to do it. But that's the delicate balance we have as people. I've been in 50 years in curation and collection management, archives, and yeah, it's always a delicate balance what one does. Um, any other comments? Are there any comments online? Let's see.
I see here one question. Where would you store physical media if the site does not belong to that group? I assume this you're talking about off-site storage.
Or I think it comes into the question of the legal, why you need a legal entity to be involved, because who really owns the objects that you are archiving, storing, protecting, and can speak for them and their future handling. Because you need these agreements if someone is donating space to you to store stuff, that's great, but who is the ultimate entity responsible for that collection? You know, it shouldn't be just a single party. Um, and sometimes, you know, obviously if it's an emergency situation like a flood, then bets are off on these things, but for something more measured.
Yeah, I think sometimes the sad grimness is that sometimes there is one continual flood, and that through track record, it's clear that the holding entity has no interest in, assisting, and that then becomes another tension.
Okay. Yeah. Yeah. Not sure I fully heard everything you said there, but um, any other comments? Well, then I'd like to thank all our speakers in this session. I have one announcement to make before we go, but first let's thank our speakers with a round of applause. Now, I do have some sad news to impart to this community, but through a message during this morning's events, I heard that Suzanne de Babar has died. Madame de Babar, as I always knew her, and known her for many years, was the Paris Observatory, a leading scholar in the history of astronomy, former president of this commission for history of astronomy, and very long time active in the field, both of history of astronomy and history of scientific instruments. And while it's not a surprise of her death because she was getting on in years, it still comes as a shock to me and I'm sure others, and a sad moment. But I hope we'll continue this meeting in celebration of her memory and life. And I just wanted to share that news with you, which was breaking news to me during the session. So we will convene back here at 1:30 for the next unit of this focus meeting. And so have a good lunch, and I look forward to seeing you this afternoon. Thank you.
Hello, is there anybody in the room yet?
I guess virtually speaking, yes. I don't know if anybody physically is there.
Well, thank you for saying that there is at least a real person somewhere, even if it is a virtual person. Thank you.
I could be an AI, you never know nowadays.
Okay, well, nice to meet you.
Is Elizabeth Jane Carruthers, who will be speaking remotely by Zoom. And her topic is the Tapashuk Restoration Project. So we'll have her share screen and we'll be off with our first talk.
Good afternoon, everyone. Just let me get this to fill the screen somehow here. No, that's not going to work. All right, I'll just leave it at that. I've got to start the slideshow, haven't I? Sorry, I thought somebody was going to be in the room a little earlier just to check that this worked properly. So I don't know how to move the slides now. Okay, I do. Sorry, but it'll have to be like this. Can
Yeah,
everyone
hold-
hear me?
what?
Can you hear me?
F5, can you hit F5? And we're having
F5.
trouble hearing you in the room. So
Okay, can I? All right, thank you very much, Sarah. Can everybody hear me now?
yes, we can.
Super. Thank you. Thank you, people, for attending my presentation. And thank you, Sarah, for chairing this session. To start with, I'd like to emphasize that I'm not an astronomer, but an academic historian with an interest in heritage. So that will be the perspective of my talk. But I don't have a complex argument to present or contribute to a big intellectual debate. But it is a pleasure to be able to outline a project that fits so perfectly into the focus theme of scientists and their impact on South African society and its native peoples. This is so because Toppieshoek is testimony to the role that a Dutch astronomer serendipitously played in one of the most significant discoveries about South Africa's pre-colonial past. I hope to cover the following topics. 1, what and where is Toppieshoek? Briefly, I'll itemize the 2 heritage sites on the property, explain the project, and then give a few details about the astronomical site and the archaeological site. And finally, I'll summarize this ongoing project, and I hope that there is some time for a discussion on how best we can conserve but also use our scientific legacy, which a couple of people have been speaking about today. So let's start. What is Toppieshoek? It means top corner in Afrikaans or even in Dutch. It's a 50-hectare rural property that belongs to Tshwane University of Technology, whose main campus is in Pretoria. And the university uses Toppieshoek, which it has inherited, as I'll come to later, as a venue for student outdoor recreation and leadership training. You can see there's an outdoor boma where students sit and listen to classes, but they also have adventure things to do on the rest of the property. It is situated in the Magaliesberg Biosphere Reserve, the Hartbeespoort Dam. It's 90 kilometers north of Johannesburg and about 60 from Pretoria. It's a vast reservoir that was built in the 1920s as a poor white empowerment project and an agricultural modernization project after the South African War. It contains 2 significant heritage sites. The one is an early Iron Age site dated to about 350 AD. And Iron Age people in Southern Africa are African farmers. They cultivate crops, they work with metal, and they make complicated pots and containers. What this site is the first evidence of Black settlement in this region. It's remarkable. It is incredibly important because this is about 1,000 years earlier than was thought at the time it was found. And it was found by an astronomer, Arnold van Genderen, who was working on this property. The second site is the Leiden University Observatory Southern Station that operated for 25 years between 1953 and 78. And remarkably, 2 telescopes dating from this era remain in the spot, the Franklin Adams and the Rockefeller Twin Astrograph. What we've tried to do with this restoration project is the following. Firstly, we wanted to research both sites for restoration, heritage accreditation, to conserve them, and to get Tshwane University of Technology to use it appropriately, and of course, the South African public to appreciate it. The project was initiated by the Magaliesburg Association for Culture and Heritage, which is a regional, very small, non-profit, non-government organization. The project was led by Vincent Carruthers and myself, and we have worked with collaborators, experts and partners, and numerous astronomers and archaeologists. And what we hope to be the outcomes is a wide recognition by TUT, who have signed a memorandum of understanding with the Magaliesburg Association. We want it to be have official status as a heritage site. We've published a small book. We've put up blue plaques, which are the international insignia of heritage places. We've put up information boards. We've written a formal report and recommendations. We've got a massive source list and bibliography. And we hope that there will be access for expert astronomers and archaeologists. Let's start with the Leiden University Observatory Southern Station, which was there for 25 years. That's what it looks like, with the Hartbeespoort Dam in the background. Those are observatory buildings and also the housing for the staff who lived there for all of that time. This station began as a collaboration between Robert Innes and Willem de Sitter, and it began in 1923 when Innes went to Leiden to accept an honorary doctorate, which was his only educational qualification. In the 1930s, the agreement was formalized that astronomers in Johannesburg could go to Leiden, and Leiden astronomers could come to Southern Africa and study the southern skies. Obviously, more Dutch astronomers came here than the other way around, but it was a huge plus for Johannesburg. Innes was the director of the Union Observatory, later became the Republic Observatory, and Willem de Sitter, equally famous, was the director of the Leiden University of Astronomy. So, what did they use? The 2 telescopes that still are extant on Toppieshoek were originally in Johannesburg at the Transvaal, later the Union, later the Republic Observatory, and were moved to Toppieshoek in the 1950s when air conditions in Johannesburg were deteriorating and there were better observing conditions way out of the city. The 2 telescopes that are there still are the Franklin Adams and the Rockefeller Twin Astrograph. There was a third instrument, and that is the one on this photograph on the right, which belonged to Theodore Valraven, and it was his light collector. It was installed at Toppieshoek amid great excitement, but it was relocated to La Silla when Leiden closed its southern station. It worked there in La Silla for quite a while. It was known as the Dutch telescope. But in fact, it was soon disbanded, but I gather it is still there, sitting in La Silla. But the building that housed this massive telescope and was specially built for the light collector has been transformed into student accommodation. So this is the Franklin Adams. It was built in 1903. After many moves, which are you can see in lots of the literature, particularly by Ian Glass, it was moved up to the Transvaal Observatory, which became the Union Observatory after the Union of South Africa in 1910. And in 1953, it moved to Toppieshoek. It's a remarkable instrument. It looks absolutely fabulous, and it did some marvelous, marvelous work. In 1914, the photographic star chart was published. It took, arguably, apparently, in 1910 by Wood, the Halley's Comet, the best picture that was ever taken. And in 1915, this was the telescope that Robert Innes used to discover Proxima Centauri. So this is a very, very important telescope, and it deserves to be looked after and restored or used in some way. 12,000 of these glass plates, talking about archives, which is the paper that I heard later this morning, were being thrown out by the South African government's CSIR, the Council for Scientific and Industrial Research. They just said they're chucking these out. Alec Jamison went to get them, 12,000 of them. And he has very amazingly found a place to curate them within the Witwatersrand University Department of Physics. And there he is digitizing, with the help of record books, 12,000 glass plates. I know that there are glass plates in Leiden as well from this telescope, and one hopes that one day they can be a proper collection and archived, as was explained to us earlier, all put together. This is what the Franklin Adams looks like now. It's rusted. Its wires are all over the place. Obviously, it doesn't move. You can see some of the workings of it, but it's not in a good shape. Obviously, the roof doesn't move off, and it can't be used. It's just been neglected there since 1978. The other telescope that's there is the Rockefeller Twin Astrograph, which was commissioned by Ejnar Hoedspring when he was out here in the 20s and 30s. When his, and in fact, what was the focus of the Johannesburg Observatory, or the Leiden Southern Station, were binary and variable stars, and the Franklin Adams was by then getting a bit out of date. The story of this telescope is amazing. It was commissioned in 1929, and it came out here in 1939, but it came out to South Africa with some very inferior lenses, because the specs that Hertzsprung had determined were simply very, very complicated. And so only after the Second World War, and after Jenner had been in the GDR, were the lenses delivered here in 1949 at vast expense. And it was installed at Toppieshoek, having moved from Johannesburg in 1957. That's another absolutely incredible telescope. This is its installation at Toppieshoek when it moved out here in 1957. And this is that photograph when it was new. And although it looks in good shape in the pictures on the right, it too is rusty, it's neglected, it's full of dust, the wires are everywhere, and obviously doesn't work. This is what you can find at Toppieshoek, very sadly. Only recently did I discover these blueprints on the left. These blueprints are how to put together the astrograph, what the foundations of the building should be. They are a treasure. And in this darkroom are boxes of plate holders. They haven't been dusted since 1980. The other thing in the center there is the astronomer's chair, and there's a picture of, I'm trying to think who it was who's sitting on it, but a remarkable photograph in the gallery. And then there is a Riefler clock, which is also perhaps restorable. I doubt it, but anyway, it is there. So these things are still in situ. And the infrastructure for moving the roofs off of the gantries, you can see, I mean, they would all have to be totally reconstructed before you could do anything with them. Right, let's move on now to the archaeological site. And the words on the screen come from Professor Revel Mason, who was at the time the doyen, or the best archaeologist in South Africa. In April 1973, a slender dark haired Hollander knocked at my office door with a brown paper bag. He was an astronomer at the Leiden Observatory near Harderbeespoort Dam. He opened the bag and poured out a pile of decorated potsherds he'd found near the observatory. Instantly, I recognized the decorations. I knew they were over 1,000 years older than those I'd found at Olifantspoort, which is another very important site. I had only found 1 or 2 in the past, and here he had a whole bag full. I can't begin to tell you how important this was, to be 1,000 years older than those found at other sites in South Africa. 1,000 years after 350 is the same kind of time that South Africa was settled by white people, and the fiction was that white people and black people had arrived in Southern Africa at the same time, and so it was sort of perfectly legitimate that settlers and black people founded a new country after many, many years of conflict. However, taking the dates back to 350, which is when British people were wandering around in blue paint and woad, was unbelievably important and changed the whole perspective and gave us an early Iron Age, which we had not had before. We've only known about many, many thousands of, or hundreds of late Iron Age sites. So this was a massive thing. Van Genderen gave his finds to the University of the Witwatersrand, which then, as you'll see in a minute, used the site. He took a few back with him to Holland because the heritage strictures were not as onerous as they are now. And he very generously arranged for them to be returned to South Africa about a year ago. The site was excavated by 2 of South Africa's most prominent archaeologists, Revel Mason on the left and Tom Huffman on the right, both of them extraordinarily competent, far-thinking and creative archaeologists who did massive amounts of good work here. This is Revel's site. He worked there for about 3 or 4 years in winter because that's the best time when the veld is brown and dry. And this is him giving a talk to archaeologists about what he had found. He covered his most critical bits of the site with corrugated iron, which were stolen very shortly afterwards. And so, and since then, or since Tom in 2000, the site hasn't been worked. What the site shows us is how early Iron Age people constructed their huts, made pottery. There's lots of clay in the area, stored their grain up on stones, as you can see in one of those little drawings. We are not sure whether they had cattle, but they certainly kept goats and sheep, and they worked metal. There is ochre in the area, which presumably was used for decorating, probably the pots as well as the people. And it is rich in iron ore, which has become sort of part of the sandy thing. Many of the rocks you pick up are magnetic. And there is a whole ritual that goes with metalworking in a pre-colonial society. And this is the earliest evidence of it in our part of Southern Africa. This is what it looks like now. It's totally overgrown. The bush has encroached. It's very difficult to see where the important elements of the site were or are. Certainly, if you wander around and you look at the ground, which is what Van Genderen had did as a person who became extremely observant because he spent his childhood in an internment camp with no toys or anything like that. So he became very observant, and he told Vincent, my husband Vincent, in an email, sometimes I look down as well as looking up. Well, his looking down was monumental. However, the site hasn't been looked at for 25 years. You can still pick up bits of slag, bits of pottery, and bits of evidence of hut roofing. Because you can see so little, these are 3 of the information boards that the Magaliesburg Association has put up recently, so that even the students who visit these sites get some clue as to what precious material there is on the ground they're walking over. The people we've been working with, there have been many of them, include on the astronomical side, John Carter, Alec Jamison, Chris Stewart has been out, Dave Phillips has been out, but I know Ian Glass has been up there, so have others been out there. And we've also been working with the archaeologists at Wits, Amanda Esterhazen and Justin Bradfield from the University of Johannesburg. They have been amazing with what they have suggested we might be able to do with the site. So, in 1978, Leiden left these telescopes to the CSIR, that is South Africa's premier scientific research centre. In 1987, the property was transferred to what was then the Technikon Pretoria. That was a kind of fancy South African term for a University of Technology, but because it was bilingual in English and Afrikaans, it became a term that was used, and there were a few of them around the country. So that says the Franklin Adams Telescope is geskenk deur the VNNR, that's the CSIR, to the Department of Education in March 1987. In 2004, this property was inherited by the Tshwane University of Technology, which after a really very, very big upheaval of South Africa's universities, which was alluded to by an earlier speaker, it became the property of the Tshwane University of Technology. So they didn't ask for it, they didn't want it, they actually are not terribly sure of what to do with this property. They'd quite like to develop it. What development means, we still have to find out. But these 4th century and 20th century heritage sites are protected by law. And this is within the Biosphere Convention, because this is a UNESCO Biosphere Reserve, and it is now the responsibility of the Tshwane University of Technology. And the project has been just to explain to the university, and they have accepted it willingly after some meetings and all sorts of persuasions and so on, that this is a massive opportunity. Within this memorandum of understanding between the MACH and TUT, we've tried to help with the research and expertise, a book and information boards. There's been some funding for this and some recommendations we have made with the help of experts. But they have to do something to assist to repair and restore the sites in some way. They're a technical university. So they've got engineers galore who can fiddle with the wiring and have their PhDs done on how these things work. I mean, it's an amazing opportunity. They should also, because they are the site owner, they have to re-register both these sites with the South African Heritage Resources Agency and investigate possible collaboration. Now, I'm just going to go back for a moment to SAHRA, S-A-H-R-A. The South African heritage legislation treats heritage as resources. In other words, you don't put a fence around them and not use them. They are resources. They are the shared inheritance of all South Africans. Once we got TUT excited, they organized a wonderful unveiling ceremony of Tobieshoek on the 9th of March, to which Davie van Jaarsveld and others from Boyden came up. So it was a huge group. And the principal of the university was there. The lady on the left is a politician. The one in the middle is me. That is the principal of the university talking. We had a choir singing the most beautiful songs. And some of Arno van Genderen's implements were put together in an exhibition which Vincent Carruthers did with the help of Sally Gore, which we can use on other occasions. This picture shows you the little booklet that we have produced on it and a 150-page report on what could be done with what they have on Tobieshoek. So the benefits to TUT are that they can protect these sites, restore the telescopes, use them for education and research. They have a bibliography, they have ideas for potential collaboration, outreach programs. And so that concludes what I have to say. And I'd like to thank the people on the list, the astronomers that I've listed, the archaeologists, the Tshwane University of Technology, the people in the MACH, and many others behind the scenes. So I'd like to just talk about this as a restoration and heritage project. And I see that Ian Glass later on this afternoon is going to be talking about cultural and intangible and tangible heritage. And this is a prime site. And at the moment, it is absolutely neglected. I think if one can walk into a darkroom that hasn't been dusted since 1987 at the latest, to find it full of a washing machine with steam everywhere and plaster peeling off the walls, this is very sad. It was a remarkable astronomical station, and it was an absolutely incredible first find of African settlement in Southern Africa. So thank you for listening, and I hope there are going to be some questions and discussions. Thank you, everyone.
Thank you, Jane. We have questions from the audience here for Jane. Any or questions from the online participants? I don't, let's see if there's someone in the. Yeah, so thank you very much. So since we're ready to move on, I think let's see, was there another, just another, thanks for your fascinating talk. So we thank you, and we will move on to our next speaker who is in the room. And I'm having the wrong thing in my hand so I can introduce you. Yes, here we go. All right, so let me introduce Hongjin Yang, who will talk about uncovering hidden logbooks of cometary observations, the case of comets Halley and Donati. Yes, that's the slides.
There's a pointer.
And I think this is the pointer up here.
This is pointer. No.
Okay. That's
It's not working.
Oh, let me find out from them. I'll try to get you a pointer, but this does advance the slides.
Okay. Yeah.
Hello, everyone. Yeah, I'll talk about that. Uncovering hidden logbooks, the case of the comet Halley and Donati. My name is Hongjin Yang from Korean Astronomy and Space Science Institute, and my collaborator is Hyojun Lee from KASI and Hyungmong Lee from Seoul National University. Especially thanks to the organizing nice in the session, Christian Skirton, and he also gave us in the useful comment. Thanks, Chris. Okay, we are all the member of the UNESCO registration promotion committee of the daily astronomical observation log. Can I use the hand mic? I cannot see. Yeah. Could you give me a hand mic? Yeah. Yeah, okay, thank you. Oh, yeah. Okay, thank you. Yes. Okay. So, it is the Korean, the heritage of Korea. For a long time, Koreans saw the heavens in their observatory. The black background is the ancient observatory in the world. It is preserved now. It was constructed in 633, and also another dynasty. Also, we have the Royal Observatory. I would like to today is that the record, astronomical observation record, especially for the comet. There are two kinds of comet observation. The first one is they are recorded in the government official record. The other one is the daily log of comet. Yeah. So during the Joseon Dynasty, from the 13th to in the 20th centuries, when the special astronomical phenomena appear, then they make the special astronomical observation team, and they recorded in the daily observation in their daily log. And when the appearance is disappeared, and they collected the daily observation log, and all of the record are preserved recorded in the Korean official document in Silog and the Force. According to the in Seonganji, it is a treatise on the Bureau of Astronomy of Joseon. The 8 of the special phenomena was recorded in daily log, and 3 of them are astronomical phenomena, such as a comet, a supernova, and a meteorite. Okay, I'll talk about the Donati and the Halley. And Donati, in the case of the Donati, it is recorded in the document, official record. So we can find in the 3 official documents regarding to the comet Donati. The first one is all the 2 records. So, however, the second and the third the document we can find in around the 60 days observations. I summarize all of the Donatical observations. Generally, when they described in observing time and directions and coronation from the North Pole, and also in some case they described in the length of the tail. I'll show that an example and more in detail. For the same date in the October 10th, one says that at dusk, the comet was seen in the west, located in the light of the first in the constellation around here, and it is belongs to that in the some asterism around here, and also the comet was seen in another constellation. I cannot. Can I explain? It cannot working in. Anyway, yeah. So it is a 5th star, so around here. Yeah. So another document says that on a clear day, a comet was seen near the 5th star of the western Chunji. It is that looks around in the opposite C type, and it is moved to the 5th to the 4th star. It means that the comet is moving to this side. So we compare the calculation of the NASA Horizon record and in Korean record. In the rest box shows that in the blue one shows that in the NASA Horizon record, and the yellow dot means in Korean record. The position is quite similar. And the bottom is also shows that in the position of the NASA Horizon and the Korean record, and the green color green dot shows that in the difference. Okay, the first summary. Donati was also observed in Korea from the Korean record chronicles. Korean royal astronomer recorded the comet location and the shape almost every day from the September 13 to October 21, 1859. In particular, the records of the comet's location and the movement from October 10 to 13 were very detailed, so allowing us to know the exact location of the comet. Also, now we can compare the position of the NASA Horizon and the Korean record, and we know that it is very similar. Although the difference of the declination between the NASA Horizon and the Korean records exists, however, the Korean records can be utilized for the modern researchers. As you know, the Donati was it was a long time observed in the European and South Africa and Africa in Cape Town. in detail. So when we use in the Korean record, we can the more deep study it in detail, I guess. Okay, next one I'll talk about the Halley comet. Halley comet has in the daily log. I showed in the daily log observations like this one. So there is two kind of informations. The previous Donati is only we have in the descriptions. However, in the case, we have two kind of informations. The first one is description. The other one is drawings. So I briefly translate in the descriptions, or we can show that the position of the comet and the shape and movement and length of tail they describe. Also, and also we can check in the using the drawings. It also contains the 5 observers, name of the observers. During the Joseon Dynasty, when the comet was appeared, then they make that kind of the daily log. However, most of them it disappeared, and in 1917, Japanese meteorologists the first reported the daily log. So at the time, they remained only 8 collection of the daily log. However, and also the USA astronomer Carl Rufus also mentioned that. However, now only 3 of them is now preserved in Yonsei University in Korea, and 3 of them in the terms. 3 of them is only we have a copy version, and the 2 of them is it disappears, so we cannot know as well now. Korean astronomy is the many Korean astronomers studied in the daily log, and we know they identified the record and the comet. The first one, 1661, is we identified in Ikejang comet, and the 5, the 1795, is we identified in the Halley's comet. So in the case of the Halley's comet, we have in the 14 pages, it is around 25 days observations. It shows that the daily observations, and we can know that the position, the movement of the position of comet, and the variation of the length of tail. So we are now studying in the 2 kind of information. The one is description, the other one is drawings, and compared to the in the NASA horizon data. In the case of another comet, and we know that the mean absolute difference is around 1.92 degrees, and the other one is 0.92. It is very exactly they recorded during Joseon Dynasty. Okay. I think the daily log is very important because it is the field observations. So it shows that the proof of the field observation, the revision, some the characters, it means that it is a field observations. And also we found that the first day, the 5 observers in the participating in the observations, and the next day, one of them must participate in the next observations. Yeah, it was at that time the observation the system. And the left side it shows that in the daily log observation there are many Chinese characters. So, however, in the official document only they summarize that a few characters. So it means that daily observation is very important to the astronomer. Yeah. So we are using this one. We can use in the 30. And it shows that the 3 kinds of the current remain and the daily log. Okay, this one. The right side of the upper comet is the great comet is 66.4, and the length of the tail is around 6 degrees, 30 degrees. Yeah, it's very famous. We also found that the information of the daily log in the newspaper in the 1577. So we know that the daily log was written at least before 1577. Yeah, so we are now trying to register the daily log to the UNESCO Memory of the World. So I will make the short movie. I would like to show you. Okay, just a summary. Yeah. There are many records of comet Donati observed in 1589 in Korean chronicles. The Donati was along with the records from the Africa and Europe, Korean historical observations could be useful resources for the study of the comet Donati. The daily log are the only field observation remaining in Korean history of over 2,000 years, and it is an important source data for the confirming who observed what and how in the Joseon dynasty. So the daily log are very valuable asset in the history of science. And in order to leave them as a precious documentary heritage of the mankind, we try to register them UNESCO Memory of the World. I'll show the movie. The running time is around 4 minutes. Yeah, it's okay. I'm sorry, the narration is something wrong. Yeah, something problem. Okay, I explained. We have a long history of astronomy, and could you volume up the sound? Volume up sound. Thank you for watching movie. So you can access and you can see the movie in YouTube. You can find it in the keyword in daily law, and you can find, or at the KASI, Korea Astronomy and Space Science Institute, then you can find that the movie. Okay, thank you. Any other questions? Yeah. They are delivered now in microphone. Yeah, please wait there.
Thank you very much. One question. You listed the kinds of astronomical events. Supernovae, comets, or supernovae no one will know where the supernovae are knowing. But you also listed meteorites. Did you mean meteorites and meteors? Maybe bright meteor? Or were they searching for stuff?
In the case of Korea, we distinguish the meteor and meteorite. In the case of meteor, they just described some shooting stars appeared. However, in the case of meteorite, the star is fall down in the underground, and you can find that. So, in the Korean history, there are several meteorite records. However, we cannot find yet because the development is quite rapidly, so we cannot find in ancient. Yeah. Thank you. However, I think that it is very interesting things when using the in historical record, we would like to find in the meteorite. Yeah. So thank you.
I have a question about the instruments that we use to observe, for example, Gladys comet.
Yeah. So in the not so many the record is historical instrument. The firstly, we know that the used in the 15th century in Sejong area, we learn the shape of the instrument from the China, and we reconstructed. The name is Gani, and also at the time they also invented many kind of the instrument at the time. So we know that at least we used in the instrument from the in 15th centuries. However, in the earlier time, we must use in the instrument. However, we cannot know what kind of the instrument were used at the time. Yeah. Okay. Thank you.
So I guess, what did you say? Great instruments are not burdened in the daily law. That document.
Yeah, the daily log is described in the very precise the degree. So it means that they must use in the instrument at the time. Yeah, thank you. Yeah.
So in verse 8, would you tell us about the main difficulty to prepare the eye for test or recognition?
You asked in the member of the who.
The equipment that prepare the eye for the UNESCO recognition of this records.
Sorry. Yeah.
What was the main difficulty that?
Okay, understand. Yeah. The first one is we win in the internet at the domestic competition. because in each country, they can in the propose only 2 items for every 2 years. So there are many in the Korean competition that exists. So the first one is that we have to win the domestic competition. However, in Korea and in the UNESCO, also thinks that it is very useful items. So they are very interesting. So we hope I think it is very positively now. Yeah. So please support us. Thank you. Yeah. Okay. When you absolutely you all of you in wondering that. However, in Korea, the made in the star chart very precise star chart in the 14th century, 13th centuries, and also it was originated from first centuries. It means that Korea has a long history of astronomy, and we make the consolidate the star map, and we use the instrument. For a long time we observe and calculate, and yeah. So I think there is no problem at the time. Yeah. So thank you. Yeah. Thank you.
So now we'll move along to our next speaker, who has recorded his PowerPoint. So it will be presented here, though Keith Snedeker, the author, is remote, so he'll be able to answer questions remotely. And the title of his talk is The Challenging Legacy of A.W. Roberts, South African Variable Star Observer.
My remarks to the memory of Brian Warner, distinguished professor at the University of Cape Town. Not only was Brian an outstanding astrophysicist, he was quite a credible historian, something of a poet and a musician, an all-around Renaissance man. And among other things, he's the one who got me in this mess. He introduced me to the history of astronomy in South Africa. So thank you, Brian, wherever you are. Now, the object of my remarks today is Scotsman, wherever you are, Alexander William Roberts, who ironically was born near the northern extremity of the island of Great Britain, but who would spend a majority of his educational and scientific career and political career, the entirety of his political career, near the southern tip of the African continent. Alex was born in Far, Scotland in 1857 to a very humble crofter family. It was a rural community. One of the pivotal decisions that his parents made early on was to move from northern Scotland to Leith, the port town, the city of Edinburgh. And there he received his primary education, in which he caught the eye of his teachers as a very bright young man, someone who could benefit from a scholarship at Moray House, which was the premier teacher education institution in Scotland in the 19th century. A scholarship. From Moray House, he proceeded to a rural school for a few years and then returned to take up another scholarship at the University of Edinburgh. But he never received a degree from Edinburgh. As a pecunious young man, he was struggling to make ends meet and to find a career for himself. But in an idealistic way, he thought that science, specifically astronomy, would be a pathway for him. And he wrote to the Astronomer Royal for Scotland asking whether there were any openings in the astronomical field. And the Astronomer Royal replied in a very discouraging note that there were few in very rare positions available in astronomy, and they weren't made by scientists but by bureaucrats based in London. So do not think about astronomy as a career pathway. Well, as a devout member of the Free Church of Scotland, Roberts was aware of various opportunities for mission educators, especially in India or Central or Southern Africa. And he applied to the Kirk and received a post at the Lovedale Missionary Institution in the Eastern Cape of what then was the Cape Colony of South Africa in 1883. He arrived at Port Elizabeth by steamer and then took an ox wagon into the interior to the little community of Alice, which is a remote post in the 1880s and even the 1890s. Finally, there was a rail link established in 1904. So he was out with a small Scottish Presbyterian community educating Africans. And his role was an educator rather than an evangelist at Lovedale. That's an important point to make. Well, what to do with his time outside of the classroom? He need only look up at the very dark and clear night sky of Southern Africa to be inspired to become knowledgeable of the stars of the Southern Hemisphere. And by 1891, he determined that observing and monitoring stars that varied in brightness was something that he could do with very modest equipment, starting out with a pair of opera glasses. In the 1890s, there were only a handful of known variable stars in the Southern Hemisphere. Roberts got his initial information from a survey done by Benjamin Gould, the American astronomer, in the 1870s. But he soon found that there were new variables to be identified, and he discovered a couple dozen of these objects, and that institutions were finding other objects that he could monitor after their initial discovery. There was almost no one in the Southern Hemisphere who was systematically watching these objects over time. And for at least 105 variables, the Roberts Archive documents 29 years of data, which is pretty extraordinary. In many cases, this is the earliest data set for those stars. And he remained an active observer to 1920. You'll note that he would live another 8 in a few minutes. Well, this is a picture of the Roberts Paper Archive at the Boyden Observatory near Bloemfontein, South Africa, in 2012, when I visited and examined much of it. Shortly after his death, Roberts' family donated his observational archive to Harvard University in its southern station in South Africa. Although Roberts had published in the monthly notices of the Royal Astronomical Society, in the Astrophysical Journal, and similar periodicals, a large majority of the data in the archive was left unanalyzed and unpublished at the time of his death. But the Harvard astronomers at the Boyden and visitors from around the world who came to Bloemfontein, although they were aware of the existence of this archive, did little or nothing with it for 6 decades. It's only in the late 1990s when members of the AAVSO begin to extract data from the paper archive. And then we have to wait to 2018 for British Library Endangered Archives grant for South Africans to begin to scan and post online the archive for wider accessibility. So a lot of the data that's to be found here is yet to be interpreted, yet to be utilized. And that's important to take on board. Also, from this remote location, Roberts was using very modest equipment. The largest telescope that he would ever have had an objective lens of 8 centimeters. And it was this telescope on the tripod in the one picture with him standing next to it, a loan from the Royal Astronomical Society. From loans, various gifts, from packing crates, he assembled, by the end of the 1890s, his observatory, and really his heyday, the first 15 years of the 20th century, where he's fairly well equipped, and is in correspondence with astronomers in Europe and the United States, and has his full list of variables that he's monitoring. Now, just a couple examples. He watched many eclipsing binary systems, perhaps most famously V Puppis, because his early case, although it was discovered by Edward Pickering of Harvard, looking at plates that were taken from Arequipa, Peru, it's Roberts who determined with very good accuracy the period of variation for the system, and who reckoned that the elements of V Puppis must be very close to one another, and that they must be tidally distorted from neat spheres to some kind of oblate spheroid shape. Roberts shared his data with George Darwin at Cambridge University. And yes, George was one of the sons of Charles Darwin in that famous family. And this is an example of Roberts having a theoretical interest in what was physically happening in these systems, and not simply being an observer who provided raw data to professional astronomers. He was most successful in interpreting binary systems and accounting for the variation through eclipsing binaries. When it came to long period variables and Cepheid variables, other types of pulsating variables, Roberts was at a loss in interpretation. And yet his decades of data could well be of value in early 21st century interpretation of these systems. And here's just a light curve of one of his favorite pulsating variables, SRA. Even though he was in a remote location, and correspondence with international scientists often took a month or longer to pursue, within the Young Union of South Africa, a political entity that only had been established in 1910, he had a sort of natural leadership position. And he was named president of the South African Association for the Advancement of Science in 1913. From about that point, he was enmeshed in the scientific movement in the young South Africa, in popularizing science, getting recognition for scientific researchers, whether they were in astronomy or other fields. The government, Union government, appointed him official delegate to the IAU General Assembly in 1925, 99 years ago. So it's appropriate that he appear in the historical session at the GA in South Africa this time around. And finally, Jan Smuts, the Prime Minister, nominated Roberts as Union Senator, a member of the upper house of the Parliament, a man of expertise to represent the majority African population in what was a white minority regime already in the early 20th century. And he was further named the senior member of the Native Affairs Commission, a body that was supposed to negotiate the interests of white South Africans with Africans, South Asians, and other residents of the Union. These were very uncomfortable political appointments for Roberts. As a moderate liberal Scotsman, he made mild suggestions to promote greater understanding among racial categories and to provide for greater educational opportunities for the majority population. And yet his suggestions to government went entirely unheeded. And this is before the period of the apartheid regime in the worst of the white supremacist era that's yet to come. So yes, not only did his government work take him away from research and his scientific advancement work, but it led to a very frustrating end to his life and his general public career. So challenging legacy, at least threefold. The Roberts Archive lay fallow for at least 6 decades. And it's just a case study and historical data, scientific data, that's almost certainly out there and is yet to be identified, interpreted, and disseminated to the 21st century scientific community. And then Roberts never held a university post or a post in a professional observatory. He was an independent or unaffiliated researcher. In his day, science was becoming increasingly professional and institutionalized. What is the status of those who are between appointments, who have never had a professional appointment? How can they be assimilated into the wider scientific community? How can they be given status? And how can their research get the full respect and attention that it deserves? And finally, the scientist's responsibility to a wider human community. The scientist has no less responsibility than an average citizen or human being to take part in the social and political issues of his day. In Robert's case, it was an especially oppressive political and social environment that he had to engage whether he liked it or not. And it led to very little advancement in his lifetime. And it was greatly to his frustration, but it acted almost like the tidal forces in close interactive binary systems, something that is a human responsibility to take on board. And that's really what I want to leave you with, even for a practitioner of a reputedly pure science, such as astronomy. There is this fundamental responsibility to all of humanity. And it's something not to be avoided. So, Alexander William Roberts, his challenging legacy. Thank you very much.
I wonder to which extent Robert's manuscript has been encoded and assigned values in is because you show me some everything in
Unfortunately, I wasn't able to hear most of the questions. Yes, can you hear me? Can you see me? Unfortunately, I can't. I suppose this is why I chose to record my my presentation.
Okay. Here? Okay.
Yeah.
We had a good question for you, but I'm guessing you didn't hear it, and
Yes,
we will.
now I can hear.
Oh, it was a question about how much of the data that had been supplied to the AAVSO has been input. I think the questioner is texting you a question on the side. So that's probably the best way to handle it now. Sorry
Okay,
for
I'd be
the
glad to respond to that. I'm sorry for the
no,
the
it's just
technical
that we're having
glitch.
some technical glitches here in the room. So thank you for your very interesting talk. So we will now move on to our last speaker of the session, which is Michael Backus, and he's in the room, which simplifies life here. And he is talking on the history of astronomy in Namibia. Slides with that.
All right, great. So, a very good day, everyone, and thank you very much to the organizers to have me in this session. I want to talk you through the last 100 years of the history of astronomy in Namibia, as far as I'm aware of it. As you see, I'm situated at the University of Namibia myself, but I'm also the chair of the Namibia Scientific Society, which will become a bit important later in this talk. This is why I want to give you a little outline about the Namibia Scientific Society first. It was founded in 1925 as a non-governmental, non-profit members association, and still is today with more than 800 members. And it was meant and still is a platform to exchange of factual information. We do that in different ways. But the most, well, one other important point that this links a bit to the previous speaker is that it's an association mainly of laymen and laywomen. It builds upon what we call working groups, and there's several of them. They have been some opened, some changed over the time. These are the current ones, and obviously you see astronomy feature there, and this is also for the reason because it was will become important for this talk and has been a very long-standing one. First, let me introduce you and bring you to Namibia. You all are in Cape Town, at least virtually now. So you have seen the African continent. You know where Cape Town is, but Namibia is just a little north of here, and 2 hours plane ride to come to the capital of Windhoek. You will certainly know the places of Meerkat and Salt. In Sutherland, you might have visited the Hess telescope situated in Namibia, and the University of Namibia situated with its main campus in Windhoek. Namibia is one of the least densely populated countries in the world, which brings with it a very dark sky, which is perfect to do astronomy under. So that's just a bit of background to bring us there. Now I want to run you through a couple of initiatives that have been happening in Namibia. Literally 100 years ago, in the 1920s, there was the Bucharest Solar Observatory set up, which was operated by the National Geographic and the Smithsonian Institution for 5 years. Down in the Bucharest Mountains, you see a picture of that mountain, which is a volcano crater on the bottom right of the slide. And the aim of that project was to measure the solar radiation constant. From what I've read, I'm not an expert on the topic itself, it didn't go too well because the site was not high enough to be free from the atmospheric effects. And so the observation site was closed down after 5 years. And I think 2 other sites were continued, one of them in the US itself. Then in the 1930s, there was in 1935, the astronomy branch of the Namibia Scientific Society founded, and that one was in conjunction to to the aim of establishing an observatory, an astronomical observatory close to Windhoek. And this initiative was spearheaded sort of externally, or the external contact there was the German professor Schönberg, who was the director of the Breslau Observatory at the time. There was, and I only put it here as a proof document because it's written in German. There was a plan to have a quite substantial telescope brought to Namibia with the ambitious aim of having a 2-meter mirror telescope placed close to Windhoek. The Windhoek municipality, according to this letter there, had already granted space for this at the radio tower and access to the buildings on that mountain for the radio tower. There was a plan to source funds locally for the erection of the dome for that telescope, and to have the telescope itself being brought in or manufactured in Germany. as you might imagine, this was an ambitious plan, and as you have not heard of the telescope yet, you can imagine that it has not happened. You can only also imagine that the time of the 1930s was not very conducive after all. Anyway, so the last information I found so far was a letter from Professor Schönberg in 1937, where he states that Carl Zeiss is working at its own cost to build or to on this 2-meter mirror project. That the observatory or the idea of that observatory received even positive noises from the German government at the time. He also states in the very same correspondence that he's a bit afraid that the government might get involved too much, because he was quite certainly not a friend of the government of that time in Germany for quite obvious reasons. Then staying in the 30s a bit, but also jumping to the 50s, Kuno Hofmeister, who, if I get it right, was a student of Prof. Schönberg, and then later on was professor himself, and I think the founding director of the Sonneberg Observatory in Germany, or of what was to become Eastern Germany later on. He had several visits to Namibia. The first set in 1937-38, and then the second set in 1952-53. He had an observing site close to Windhoek as well, was as depicted there in the image to the bottom left, was using, I think, a 13-centimeter refractor, and was cataloging variable stars, also linked to the very previous speaker. And there is, well, possibly contrary to the previous speaker, there is literally tens and tens publications by him that you easily find on the ADS. Much later, more like 20 years ago, an amateur astronomer, his name is Sonja Etting-Enke, built a private observatory in Namibia, just south of Windhoek, and named it in memory of Kuno Hofmeister Memorial Observatory, as she literally grew up in the very vicinity of the Sonneberg Observatory herself in the 1930s. Then there is a lot of history about trying to establish the Gamsberg Mountain as an astronomical observatory in Namibia. And there were several attempts, and I will try to run through them here in this presentation. The first one that I'm aware of is in the 1970s, where the Max Planck Institute of Astronomy, which was just newly founded, was set to have a Southern Hemisphere observatory set up. So the possible sites were searched for. The Gamsberg Mountain was identified, was eventually bought in 1970. Then telescopes were produced. There was a discussion. They were producing a 3.5-meter telescope and a 2.2-meter telescope. They also established a northern observatory, which was to become the Cala Alto one. And so discussions were which telescope to place where. It was fairly early on decided to have the 3.5-meter rather in the northern hemisphere, so the 2.2-meter should come to the Gamsberg Mountain. But eventually, it was forbidden by government because of the UN sanctions against apartheid South Africa, which was sort of not following, well, on the one hand, because of the apartheid regime, but on the other hand, also because of not letting go Namibia in to become an independent country, which only happened in 1990. So by that, the Germany, or West Germany at the time, which had just joined the UN, was not allowed to collaborate there with investments. And then the telescope was eventually shipped to the ESO site and was operational then from 1984. The measurements that were done during that time still were done with a 50-centimeter telescope, and there was a professional astronomer by the name Thorsten Neckel who did, and students who did measurements. The one thing they did was they measured the seeing on the Gamsberg, which was literally the same as the seeing in La Silla. So here you see SWA for Southwest Africa, of what was to become Namibia, and CH for Chile, which was the La Silla site. Then there was in the 90s, and I'm pretty sure several people in the room will know much better and much more details about this than I do. There was a plan to build the Southern African Large Telescope, and there was a proposal in 1993 to build it as a 3.5-meter telescope of the same type as the NTT of ESO. The plan was to have the Max Planck Society sort of cover the investment costs for the telescope, to have the Republic of South Africa to cover the operations, and Namibia to cover the infrastructure. None of that eventually realized. You see, 1993 was also just before the first open and free elections in South Africa. So with a big governmental change there, which did not help the project, even though it was reported even in 94 that it was or reported in Nature that it was pretty close to being concluded, but also that in the end didn't realize. Then there was a campaign by ESO a little later, 1994 to 95, to establish the Gamsberg as possible site for the Very Large Telescope. I'm not 100% sure how serious this was, but it was certainly not a bad idea to have a possible backup site, which was not then just the Paranal site in Chile. Then in the 2000s, and still today, there's the Hass telescopes, which are doing magnificent science. I don't want to tell much about that because there's a booth down, and I'm hoping to see many of you there. And then the latest initiative in the 2020s is the Africa Millimeter Telescope, where we, together with colleagues, mostly in the Netherlands, but also in Oxford and in Finland, are trying to set up the first millimeter wave telescope in Africa. And there, I hope to see many of you in the special session we will have on Monday between 1:30 and 3 at the Protea room. This gives rise to the idea we have developed to not just have the AMT as one telescope on the Gamsberg Mountain, but to again try to have the Gamsberg developed into an actual full observatory site. And we wrote down that idea just recently, a year ago. And after having talked about the Gamsberg, let me show again how it looks like. So you see, this is well, the laser pointer is not working. Anyways, this is a natural flat top mountain with 3 kilometers in length and between 400 and 800 meters in width. There is currently a 70-centimeter amateur telescope that is used by the International Amateur Observatory. That's where we want to bring the Africa Millimeter Telescope up. And you can quite easily imagine that the road that you see there in the very picture is not quite as sturdy, so to say, as as you want it to be to bring up large-scale equipment. So there's a little picture on the mountaintop, and you see it's just a magnificent place to build an observatory. With that, I want to thank you and give you a little glimpse into the future, having talked about the past. So there is quite a couple of Namibian students with me here who are operating a mobile planetarium, which is currently doing outreach in schools and will be here at the venue tomorrow also for everyone who's interested in that. Thank you all.
So please come up and try to ask questions here because this mic is not, they're not hearing it on Zoom.
I'm the second one. I'm sorry, he is the first one, I'm the second.
Maybe it's a short question, we can go ahead. Like I should.
Go ahead, we're must add it to mine.
Yeah. Thank you for your excellent talk. I'm actually visiting Namibia next week. This is a very timely talk. And you mentioned several early attempts for the astronomical observations. I wonder any of these materials are preserved in one of the archives in Namibia. Last year, I went to the National Library in Namibia, but I couldn't find anything. And I wonder where the early observational records are preserved for such attempts.
Well, I'm not entirely sure they're preserved anywhere in one place, so to say. But you're very welcome to join us at the Namibia Scientific Society, where we host a large reference library. I cannot promise you that you will find something there, but it's certainly worth a try. Yes.
Well, thank you very, very much. And I have a remark concerning Hofmeister's activities in Namibia. First, he visited Namibia in 1937, and you clearly see that he was a Nazi party member. It is so. But a very strange thing that he was able to come in the time of the German Democratic Republic. And Sonneberg is very close to the border with Western Germany, and almost no one could travel. It's a very strange thing for me how this guy could travel. And my final remark is, among his observations there were also visual observations of a variable star with 0.1 magnitude amplitude and an excellent light curve. So he was a fantastic observer. Thank you for raising this point about Hofmeister in Namibia.
Any other questions? All right, well, we're now at the top of the hour and the coffee break. So let's thank our recent speaker and all the speakers for this session. And in a half hour, we will reconvene for the final session of this focus meeting. Thank you all.
Test. 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 Test.
Hello, volume sounds good this side.
It's working, okay?
I can hear you.
Great, thank you.
So our first presenter is actually in Paris. That's Isabelle Lemenon. And is she on
Yes,
online?
yes, I'm here. Can you hear me?
Yes, we can.
Oh,
Well, I
great.
can't see you.
Ah, okay. My video is on and I can see it on the Zoom screen.
Now we can.
Ah,
Excellent.
okay, great.
So Isabelle is in Paris, and she's going to talk to us about female computers at the Cape Observatory. So Isabelle, how long do you have? Is it 20 minutes?
Yes, 20 minutes.
Okay, please go ahead.
Thank you. So, hi everyone. I'm very happy to be with you today, even if in the virtual room with my colleague Colette Lelay, whom I worked for this presentation. And as the time slot is very short, I will be the one speaking, but we work together for this talk. First of all, let me thank Christian Stirken, the International Astronomical Union, and the French Network of History of Mathematics for supporting our research and participation in this conference. Colette Lelay and I want to dedicate this presentation to the memory of Suzanne Debaba, a French astronomer and historian of astronomy from Paris Observatory, who just passed away. She contributed extensively to the history of astronomy, and she both helped us in our research. So today I will be speaking alone. I'll be talking about women computers at the Royal Cape Observatory between 1890s and the 1930s. After a brief introduction to the general astronomical context of this period and the employment of women in astronomy, I will question their presence in the ranks of astronomers at the Cape before examining their functions. Diving into the archives, we will discover the troubles caused by women at the Cape Observatory, according to the royal astronomers. Between 1890 and 1933, the Cape Observatory was headed by 3 royal astronomers under the direction of Greenwich Observatory. Sir David Gill between 1879 and 1907, Sidney Samuel Huff, 1907 to 1923, and Sir Harold Spencer Jones between 1923 and 1933. As we already heard yesterday, during this period, several international astronomical programs were launched. La Carte du Ciel in 1887, which started in summer 1891, and in which the Cape Observatory took part along with 17 other observatories around the world. And Ileana talked about that yesterday. Edward Pickering project starting in 1891 in Harvard. The CPD catalog made by Gill and which was presented yesterday by John. The International Astronomical Ephemeridis starting in 1911, and another one, the International Bureau of Time, started officially in 1913, but in reality in 1919 because of World War I. At the same time, women were started to be employed in the observatories as the staff members. First, for example, in Paris, in 1882, Bouquet de Lagris used the female computers to computate the transit of Venus. Later on, the Carte du Ciel employed several women, and the International Committee of the Carte du Ciel wrote in 1889 a workshop of 10 or 15 women with as many machines and 2 or 3 people to run them would be sufficient for this work, which could be organized with 60,000 or 80,000 francs per year, that is to say with 5,000 francs at most from each interested state. So I will not describe more the Carte du Ciel project as Iliana talked about it yesterday. So this whole idea of employing women for the Carte du Ciel project was accepted, among others, by David Gill in the Cape. He wrote to Mouchet in Paris in 1891, of course, if we can get the money, there is no reason why we should not make the measures here in the Cape, but women's work for this purpose can be procured in Europe at so much less cost than here. And we will see later on that the question of the lack of money for the project is very essential for Gill and his successor to be able to employ computers. At the same period of time, Edward Pickering workshop was employing several women computers in the Harvard Observatory. And also another moment which I think is very important for David Gill and the employment of women is his invitation to Agnes Clerc, who came to the Cape Observatory in 1888, where she could make observations with Gill, who was very impressed by her knowledge. Later, in 1892 to 1901, in Paris, the Bureau of la Carte du Ciel was headed by Dorothea Klunk, that you can see on the upper image on the left, who was heading the bureau, employing several women. And later on, in 1919, Edmé Chandon in Paris Observatory was entrusted the Bureau de l'Heure, the time department of the Paris Observatory. This official introduction of women into observatories in Europe, the States, Australia, and many other countries has already been highlighted by historiography. But what about the Cape Observatory? This photo of the observatory staff in 1879 isn't very encouraging, but, sorry. By 1913, as you can see, things had changed. Around Sir Gill, the royal astronomers, you can see the assistant astronomers, the computers, women and men, and either Mrs. Gill or the secretary, I don't know yet. But you can see that there are at least 8 women computers in the photograph, which is confirmed by Sir Gill reports to Greenwich Observatory. You can see here that in the successive reports by Gill, Huff, and Jones, that the number of women computers is very important out of the total of computers between 1896 to 1933. But what about this category of computers in the Cape Observatory hierarchy? The archives, and in particular the nominative list of staff between 1820 to 1931, provides a better understanding of this organization. So the head of the observatory was the royal astronomer, assisted by many assistants. The more important one was the chief assistant or first assistant. We can find both names in the archives. The assistants, the second-class assistants, and the lower class is the junior assistant. And when you were recruited in junior assistant, there were possibility to go up in the hierarchy. There was also the secretary, librarian, and accountant. And the last categories, the computers or clerks. There are the 2 words in the archives to describe this category. And within this category, there are the established computers of the higher grades, the established computers, and temporary or supernumerary computers. And that is the category in which women are. So there is no surprise here because that is the same that in Greenwich Observatory. Here is a list of the women employed in astrographic measurements, so the carte du ciel, but not only, with their names, initials, start and end dates of their careers, if I may use that word, at the observatory. So you can see that some of them just stayed a few months working as a computer or measurers at the observatory, but some of us stayed longer. For example, Miss Stephens, that you can see here, has the longest career of any women, almost 36 years working as in the astrographic measurements. But as you see, she didn't measure, she was computing. Another one, which is not on this list, is Miss Carney, who worked for 35 years at the observatory as typist, assistant librarian, doing clerical work, but also computing. So what did these women were doing at the observatory? First of all, it must be stressed that one of the crucial issues throughout these years was recruiting competent personnel, as the Royal Astronomer Sir Hough wrote in 1914. There is great difficulty in obtaining locally the temporary assistance of competent persons capable of being trained to work to the observatory. In this letter to the Royal Astronomer of Greenwich, he recalls the task entrusted to women. The photographic part of the work for the mapping of the heavens was virtually completed in 1907, temporary computers being for the most part employed for the purpose. Before that time in part, and subsequently almost entirely the heavy office work, comprising the measurements of the plates and the preparation of a catalogue or index to their contents, has been principally carried out by a staff of lady computers specially engaged and trained for the purpose. The same computers have also assisted in other branches of the observatory work. In this letter, we don't know exactly what are these other branches of the observatory, but I will give you some other leads a bit later. So the CAPS catalog of astrographic zones gives us more information on the division of tasks between women and on their responsibilities, as you can see here. The carte du ciel computers were placed under the direction of a woman, Miss Bowman, and later on, Miss van der Lingen, which is the same case that in Paris Observatory, where the Bureau de la Carte du Ciel was headed by a woman. They measured the plates, reduced and prepared the data, except for a few women who only did the computation, like Miss Beatty, Miss Carney, Duncan, Ness, Sampson, and Wilson. Their names, or rather initials, appear throughout the Carte du Ciel catalogue produced at the Capes, as you can see here. Working in pairs, each plate is associated with the initials of the two women or men who carried out the measurements and computation. For example, here in yellow, plate 52 was taken care of by Miss Coates and Miss van der Lingen. So you can see on the bottom left in yellow, MC are the initials of Miss Coates and L is the initial of Miss van der Lingen, and the plate 52 was measured by L and MC. So the whole catalog contains all the participation, the measurements and participation of women printed in it. Throughout the reports sent to Greenwich, we can list the tasks taken on by 30 Cape women computers, which were not limited to astrographic work on the Carte du Ciel. They work on data from the astrographic telescope, the Victoria telescope, and the Meridian cycle. They could do both measurements or computations for the Carte du Ciel, but also for other projects. They worked at the time department, which I think was the same thing that the transit cycle department later. The astrophysical department, she could work on the determination of parallax and reduce zenith distance observations. But these women were not without causing troubles for the observatory, according to Royal Astronomer David Gill. In fact, according to him, they mutinied, as he explains here. The mutiny of the ladies has been a very disastrous business. I have only 2 fairly capable ones and 1 young girl that can only copy. They are all reaching up to Johannesburg, where they get 16 to 25 pounds a month as copyist or typist. How could he understand that women were leaving their temporary jobs at the observatory for better paid permanent positions? What a shock! In fact, the archives show a large number of male and female computers living in 1901 and 1902. And this departure of many computers may have led to an increase of the salary after 1902. As you can see here, you have the expensive for the project of mapping of the heavens, which was sent to the Greenwich Observatory. And in 1901, 1902, the amount is 540 pounds. And later on, so that are the years where all the computers were leaving the Cape Observatory. And in 1904, 1905, there was a small raise of the expenses, 616, and 1905, in 1906, there's a bigger raise because the expense is 880 pounds. I have to add that at that time, during all the 6 years, there were the same number of women working at the mapping of the heavens, because we have the list of them, as I showed you earlier. And we know there were always the same number, which is around 6 ladies working in this project. So the amount of money was to be shared between these 6 ladies, and also for extra works done by men. So we can see here that at the most they could earn about 90 pounds a year, which is less than they could earn living to Johannesburg. As a comparison, historiography shows that the lady computers at Greenwich in 10 years earlier were earning between 48 to 96 pounds a year.
Can you finish in 1 minute, please?
Oh, 1 minute. Can you give me 2?
1.5.
Great. Another complication created by women is that, according to Greenwich Royal astronomers such as Frank Dyson, they couldn't make observations at night. As you can see here, that was a very common understanding between royal astronomers. So the Admiralty and Royal Astronomer Harold Jones decided to change the rules for recruiting junior assistant astronomer from the computer, which led to blocking the career advancements for women, except in exceptional cases, which were that they had to accept to make night observation, which was difficult because of gender rules at that time. So to conclude, the employment of women computers continued throughout the history of the Cape Observatory, and by the 1950s, they accounted for the majority of the computing staff. We still have to determine their social background and education, but that will be for the future. It is important to emphasize that despite the long-standing use of women to carry out astronomical observations and computation for observatories, at least since the 17th century, even at the beginning of the 20th century in the Cape Observatory, they were still confined to the same task, like in many other observatories, with no real possibility of joining the ranks of astronomers, unlike the Paris Observatory from 1907. The integration of female astronomy students to the Cape Observatories in the 50s was a first step towards greater equity and diversity in the leading position at the Cape Observatory. And beyond that, led nowadays to welcome in astrophysics, among others, the first women PhD of Cape Town University, Marie Corsaga in 2020, or Charissa Burton, first women PhD in astrophysics in Pretoria. New prospects are opening up for women of South Africa in astronomy and astrophysics. So Colette and I are thanking you very much.
Okay, so thank you, Isabel. We have time for one quick question only. Any? Ian?
When I got to the observatory in 1970, it was the last few months of the Royal Observatory. Yeah. And it's more a statement than a question, by the way. But two of the ladies mentioned here were still around. But also, I want to mention that earlier in the century, in Gill's time, it was considered a very respectable occupation for a young lady to be a computer at the observatory. It was much more appropriate than working in a shop, for example. But as you saw, they didn't stay very long usually. It's pretty boring. And there were still lady computers when I got there. Their job was not just measuring plates and doing sums, but also they did things like developing plates. There was one lady who even worked at night on the kinesiodolite. And in general, they did things like the routine measurements of taking plates of the sun and measuring the weather and things like that. So they still were around, and there's still lots of ladies working there in these kind of jobs, but nowadays they're not called lady computers anymore.
Thank you very much.
Thank you, Ian, and thank you very much, Isabel, for your fascinating talk. And we must press on. David van Jaarsveld. Sorry if I mispronounced your name. I can't pronounce myself. So, David, you're going to talk about Bloemfontein. Is that right?
Yes, Boyden Observatory. Which is this? Okay. Right, I've got a lot of to cover, so I'll be quick. I'm going to ask questions afterwards. That's a joke. You may laugh now. Right. So this is Boyden Observatory from there. Does it work? To the left, the building on the left here, I see I've got a light here. This is more or less where we have the museum that I've started. The rest are now telescopes and so on, but I'll come to them later on. Right, this is the library inside the museum where I have a lot of books on exhibit. I found the most fascinating and wonderful books like Tutankhamun's tombstone. On the left there, you'll see old Edward Pickering. On the right, William Bond, who was the first director, and I found some of his personal books. I don't know how it got there, but it's wonderful that I found some of his books there. He was director and started in 1838 at Boyden, at Howard College Observatory. This is to the other side, so I've got a lot of atlases, hand-drawn atlases that I found it there at the back. That cabinet you see is an atlas cabinet. So some of the atlases are wonderful. The one on top there is it's mentioned earlier, by, I think, Ian. It was the world's first photographic atlas of the Great Magellanic Cloud, which was done from Boyden. The one at the bottom here is Palesa and Wolf photographic atlas. Then some of the books that I discovered there are the Harvard annuals with the drawings still in. It's long before astrophysics photography. So there's one that still speaks about the Andromeda Nebula with the drawing there. And then next to that, I've got a photo of the Andromeda Galaxy, which we now know. This one is wonderful. That is the Moon Atlas drawn by Julius Schmidt from Berlin Observatory. He drew this like the whole atlas. I could only show these 2 pages there, but he went forth and drew the 6,600 craters that you could see through his telescope. Hello, Saki. Right, now this is the only thing I have of old Boyden. Boyden was the beneficiary of Boyden Observatory out of his estate, and I discovered this book in the library that actually belonged to him, so that is quite precious for me. And then, speaking of women computers, these are the 2 most famous in my account. And at the left there, with the Cepheid variable stars discovery, and then any jump cannon with a magnificent work of 350,000 stars being catalogued, all from Boyden Observatory photographic plates. This is something wonderful. I call it the glass universe. It is the world's first photographic atlas of the whole sky, published by Edward Pickering in 1903. 55 plates covering the northern and the southern hemisphere. It was done from Boyden, of course, for the southern hemisphere, and then from Harvard College Observatory in the north. And there you see at the back the 1-inch Cooke lens that took those pictures. So I took each picture and photographic plate scanned it. There you can see the one number 25, and I put it through astrometry.net, and it shows you exactly what's on the plate in the right here corner. You can see exactly where it is in the sky. So that was wonderful. I put it up like a puzzle in exactly where each one must be. So that is the whole sky, 1903, the world's first photographic atlas of the whole sky. Right, there's another example of 2 of the plates. So each plate I showed a constellation, a star, and then 1 object. So I have to, especially for the children coming there, the learners, that little dot you see there, that's a galaxy containing 100,000 million stars in it. But for us in that plate, and certainly for Edward Pickering way back when, it looked like a star. But actually, it is 100,000 million stars in a dot. And I also have to explain to them what the negative photograph is. They have no idea. The younger generation, 30 and younger, if you talk about the negative photograph, they look at you if you've just lined up for Mars, so that's also a challenge, but we work on that. And then on top, I've got this positive, I call it the positive of the Milky Way. There you can see the 2 Magellanic Clouds here. And then I show the learners of the public, this is what it looks like. If you have got infrared eyes, this is what William Pickering took with these cameras. Right, now we have the common mirror. And Phil, I'm watching you there at the back there. I'm watching you. Right. Sarah also showed us this picture. Now, this is the 16-inch telescope, reflecting telescope at Boyden with a Newtonian focus. At the top is Michael Bester. He was 38 years an observer there. And then you can see the rods coming down because the mirror was too thin and too light for the telescope. So you had the astigmatism problem. Then that mirror was removed in 1968 and replaced by a thick 3-ton mirror. And then that common mirror, I call it the common mirror, was stored at Boyden in the dome of the 16-inch for 50 years. Then we got it out, we lifted it up. It was a big undertaking. And then I had a cage for it built to exhibit it. And everybody said I must make a hole in the roof and let it down in the hole. So the hole to say, well, the wheel is invented long ago. I don't know what the problem was. So we strapped it on that that cage I made for it, and we lifted it up, and there you can see we pushed it through, and voila, there's the common mirror. And then I made an exhibit of the common mirror. There you is. So that was the biggest glass mirror in the world for 1890. Common built it outside his home in Ealing, outside London. So imagine that, building outside at your backyard, one of the biggest telescopes in the world. The only one that was bigger was Ross's telescope in Ireland at Burghcastle. That was a bit bigger, but that was not glass. That was some kind of metal. So at the back side of the mirror, I've got at the bottom here, I've got an exhibit of how they built the telescope, and then there you can see the instruments that was used at the Newtonian focus. On the left is the secondary mirror. Then you've got a spectrograph, photographic plate holder, and a polarimeter that was used all the way upstairs at the Newtonian focus. So you had to keep your balance, really. One of the astronomers did fall and he broke his arm, and that was quite a consternation. So you had to be sober when you stood and work on the Newtonian focus of 16. So that is that. At the sides on the left is Common, Andrew Ainsley Common, who made that mirror, and at the right is the time when Harvard used it with the telescope at Harvard College Observatory, but that wasn't very successful. And they built the 60-inch at Boyden especially for that mirror, even though it had to be replaced later on. Right, so at the top here, I've got few of the photos that was taken with this mirror, the black and white photos, and just next to it there is a Hubble photo of the same object. So I'm trying to show to the public that how the technology has improved over about 60 years. So that is quite an interesting. That keeps everyone quiet, if they look at that. Right, there's the 16-inch today in the dome, and it is also part of the exhibit of the museum. So all the groups that come here, last year we had about 17,000 learners and public that came through Boyden. They first go to the planetarium, then they come to Boyden, and this is part of the exhibit to show them the 60-inch, the big telescope. And this is the Boyden Council exhibit. Now, Sarah mentioned that the Boyden Council was the world's first international observatory, 1954 till 1976. Harvard decided about 1950 that they're going to withdraw from Boyden because of financial constraints, and then Northern Ireland Observatory decided that they will go in partnership with the observatories from Ireland, Northern Ireland, Germany, Belgium, Sweden, and later on South Africa, to form this partnership that was the forerunner of the ESO later on. All right, so the first time in the world that different observatories come together to work and operate one observatory, and that was at Boyden, 1954. That's from the other side. There you see on the right, it developed into the European Sun Observatory in Chile. And this is one of the instruments they used. It's a photometer that was used on the back of the telescopes. And it was a step higher than the photographic plates. So on the bottom left there, you can see it's a charts, charging the variable stars that they were studying. Right, some of the famous people that visited there, except me. On the left is Lindsay, and then Jan Oort and George Lamartre, and Ramberg from Sweden. Some of the people that visited during the Boyden Council days. Right, this is the famous one, 13-inch Alvan Clark telescope. This telescope is quite famous in the history of astronomy. First of all, it took the world's first pictures of Mars in 1888 by William Pickering. First pictures of Mars was taken from this telescope, 1888, from Harvard itself. And around it, I have these light boxes. There's a circle of Mars. I cannot go into that. I don't have the time for that. But in the evening, when the public and the school children look through the telescope, we've got these light boxes at the side on the wall, showing them what they are looking at and telling them about the history of this telescope. And what makes this telescope even more famous is the fact that most of the spectrum plates that was used by energy jump cannon to catalog the 350,000 stars was taken with this telescope. All right, so those are the two of the objective prisms that was used by this telescope. And at the top there you see one of the spectrum plates, and then the stars that was taken with a normal telescope, and then on the bottom the logbook in writing about that plate you see on the top there. So it's a whole coming together of the work of the spectrum plates taken with that telescope, and also a micrometer used before photography on the telescope. And this is what we do. So we've got lots and lots of learners. Even tonight, I'm not there, but even tonight there's a school coming, about 120 learners. So we have a Boyden Science Center there. They will first go to the planetarium in the afternoon. In the evening, they come and look for this telescope. This is the most amazing part of my work, I tell you that. To have a child like that coming from rural areas, look through the telescope at Saturn or the moon, and that expression on their faces, it is irreplaceable. It's absolutely wonderful. That no money can buy that. So what we're trying to do is, we call it what's the word I'm looking for? Attitudinal. So we wanted to change the learner's attitude to the science subjects. Because I tell them, when they come there, everything you've seen today, everything we taught you and we told you, is the basis of that all is mathematics. That's the basis of all science. So if you, after this, open your mathematics textbook, remember this. This is what happens when you apply mathematics to astrophysics, and then the whole of the heavens open up for you. So that's what we're trying to do there. All right, so there's my students. I'm a lecturer in community service learning. So my students, there you can see some of them, they help the underprivileged schools with the science subjects. They are science students in the third year. And then I teach them how to teach. And then they will teach the learners the science subjects. And there they also have a look through the telescope. All right, you've heard a lot about Alexander Roberts from Keith and Oka. That's the exhibit I have of Roberts. Donated was his whole, to Boyden was his whole library, and his 70,000 observations he made. And miraculously, by God's grace, I discovered his telescope, 1838 Ross 3.5-inch telescope in a garage in Gauteng. That's a province up to the north. And the whole exhibit is complete now. Okay. Okay, you've asked about, was it you? You asked about this accessibility, right? Now, the work that Oka did is that his whole, all his works have been digitized, and it is online, so you can have a look. We'll talk about that later on. Let me just, right. There is Keith Sneddegaard, who just spoke to you, working with his, to the records, and he wrote a book on Alexander Roberts, which I highly recommend for you to read. It's amazing. It's an amazing book, amazing life, and in an amazing time, which we cannot imagine now, but there was such a time. And there is Oka's photograph with his Center of Astronomical Heritage that digitized in the whole of the Roberts archives. And you can find that is also a job and all. It took him a few years to get that done. And you can find it here in the Endangered Archive program from the British Library. He got a grant to digitize Robert's papers, and there you can find it. Whatever you look, you can find it there. So take a picture of that, or you can Just remind me later. Let's take a picture. Just get it in focus, ne? So there you can find it, and there's also he also digitized all the lantern slides of Boyden and all the photographic plates. Right. So this is what is it? I've got 8 minutes. 3 minutes. Right. This is another observatory that's also in Bloemfontein. It belonged to the University of Michigan. It was built in 1928. So Bloemfontein was the only city in the world that had 2 professional observatories for 50 years. They studied double stars, and thank you to Patrick Seicher, who opened up this whole new world for us. He contacted us and asked us, do you know what's on the top of Naval Hill? That's a hill in Bloemfontein. We said that was an observatory, but we knew nothing else. So that opened up a world for us. This was a telescope inside. It was a 27-inch refractor telescope built, sponsored by Lamont. This is the telescope inside the dome. And there's Rossiter. He worked there for 25 years, calculating and studying double stars for Michigan University. There's an exhibit I have of the observatory at Boyden. And then there, Patrick is open up the new exhibit I just opened a few months ago at the observatory itself. And there people are watching the posters I have. And from this observatory, Schleifer, Earl Schleifer from Lowell Observatory, took 60,000 pictures of Mars from 1939 to 1956. With that camera, there you see the camera looks like just a copper pipe, but it's actually a planetary camera. And with that camera, he took the world's first color picture of Mars in 1939 from Bloemfontein. So we've got the telescope that took the first picture of Mars, 1888, and the camera that took the first color picture of Mars, all at the museum. Right, so there's the camera. It's still in its crate. How we found it, with the polish and all. And it's in the exhibit at Boyden. This is what happened to the telescope. It was demolished by the municipality of Bloemfontein. After Michigan withdrew, they didn't leave it there. They decided to demolish it. But we packed it up. We restored it. And we put it together again. Voila. There you see, that's in front of the dome of its old home. Welded it together. And there you are. That is as exhibit. And inside the dome, we've got the first digital planetarium in Southern Africa. And there's the SALT, South African Large Telescope Board, that opened up that little plate for us. And I thank you. Yes, sir. Yeah. You can, yeah, you just come. Yeah, alsjeblieft, otherwise.
Many thanks, excellent talk. I am very excited to be able to see all the references for Robert's logbooks. And when you showed me the picture of the library, I saw probably many more logbooks from other people. And I wonder if there are any kinds of catalogs for the manuscripts in Boyden Observatory. And this is the first question. The second question is, I'm probably coming to Boyden, Bloemfontein in the end of the month. And I wonder what kind of procedure do I have for accessibility for the library or archives?
Yeah. Okay, I've cataloged the library, all 5,000 books of them, and you can speak to me afterwards. So I will gladly receive you there. If you can bribe me, we can talk. That's a joke. What's it with you guys? Don't you laugh at my jokes? Huh? So I also have an insight. Any more questions?
Well, there's no time for more questions, so
Right.
thank you so much.
Anytime.
And now we have Ian Tasker from Sydney talking about collaboration between Sydney Observatory and Union Observatory in Johannesburg. You have 20 minutes.
Why? Mwene. In English, that means, how are you all? I've been fortunate that some of the people back at my hotel have taken it upon themselves to teach me a little bit about their language. And just for my family at home, if you don't mind, I'm just going to take a quick happy snap. Thank you. Wayne Orstenson has written extensively about RTA Innes, who was a Scottish astronomer. And there's a little story that I haven't seen it published anywhere, so that's the story that I'm going to share with you this afternoon. My research focuses on a phenomena, this phenomena shown up here on the screen, is that affects the funding of science. In the early 20th century, two remarkable astronomers, Innes and Cook, embarked on a mission to reshape the astronomical research landscape. Their collaboration, set against the backdrop of World War I, was not just a quest for scientific discovery, but a testament to resilience and innovation in the face of unprecedented financial constraints. This story delves into how their partnership, born out of necessity, pushed the boundaries of what was possible in astronomy. Innes was a Scottish amateur astronomer who turned professional, and Cook, a dedicated scientist with access to vast historical resources, were determined to overcome the financial hurdles that hindered their research output. Their shared passion for the stars and a commitment to scientific progress united them across the continents. The Union Observatory in Johannesburg and Sydney Observatory in Australia, the physical manifestations of their collaboration, became the focal point of their joint efforts. Through geographic distance, these institutions were bound by the astronomers' mutual goal of advancing colonial astronomy despite the overarching challenges of the time. Constitutional ambiguities heavily influenced the development of Australian colonial astronomy during the period. Debates about funding and oversight of observatories often created obstacles, but they also highlighted the need for a cohesive approach to scientific endeavours. Innes and Cook's primary focus on sharing resources and data to maximise their research output and impact. One of their fundamental techniques was blinking, a method of studying star proper motion by comparing photographic plates taken 10 to 20 years apart, and previous speakers have already addressed that. This innovative approach allowed Innes to detect even the slightest changes in the positions of stars, leading to groundbreaking discoveries. In a historical context, Innes transitioned from an amateur to a professional astronomer was in part due to Cook's support and resources. In fact, Innes had applied for several positions that Cook won. Firstly, to take up a position in Perth Observatory, and later on to take up a position in Sydney Observatory. Cook had access to historical photographic plates, some dating back to the 19th century, which was instrumental in the research paired with his latest series. Cook's collection of photographic plates provided a rich historical record that was essential for their study of the night sky. These plates were captured using advanced camera techniques of the day, developed by Henry Russell, previous New South Wales government astronomer, which allowed for detailed and precise observations. Cook did not personally consider Russell's plates of good enough quality to be published under his name in the astrographic catalogue due to plate fogging. However, he did see them as satisfactory for blinking. One of the significant challenges Innes and Cook faced was the need for more government financial backing, particularly during wartime. This lack of support forced them to rely heavily on personal resources and the goodwill of their colleagues. These are lessons that we still apply today. Despite their financial constraints, Innes and Cook continued to innovate and collaborate, finding ways to share resources and data that led to significant scientific progress of the day. Through their collaboration, Innes processed and analysed vast amounts of data, leading to new insights and discoveries. Their work with historical observations provided fresh perspectives on past astronomical records. In the scientific progress, their achievements were notable, particularly given the financial and technical constraints that they operated under. Their work demonstrated that innovation is possible, even in the most challenging of situations and circumstances. The collaboration between Innes and Cook represented a crucial chapter in the history of astronomical research and deserves much more attention. And one of my goals of attending this conference has been to link up with people who I can progress this work with. Their ability to innovate despite constraints underscores the importance of resourcefulness and collaboration in all scientific progress. Over the last 14 years, I've developed a new way of determining the viability of an institution, especially in the realms of getting funding, because in so many circumstances, the collaborations we do today need the resources of multiple institutions across multiple countries. And it's important that we have different methods of how to determine whether a project goes beyond being feasible and in fact politically becomes viable. I found that I actually had to define what viability was because I would see in newspapers that typically the political opposition would question whether a project was viable when the project was typically halfway through, on budget and on time. But they would try to throw doubt into the mix just to win political points. So viability as a term has a lot of negative connotations. And I've actually had to use the history of science as a superset, history of astronomy as a subset of the history of science. And I've used constitutional law as a superset to look at social psychology so that I can determine quantitatively and qualitatively whether a project or a program are viable. Innes and Cook's work was not just a chapter but a crucial turning point in the history of astronomical research. Their dedication and collaboration efforts are remembered as pivotal moments that significantly advanced science. And it's interesting to have a mechanism or a model to actually measure just how significant that was. The key takeaway for my presentation this afternoon is the story of Innes and Cooks underscores the vital role that we have in collaboration and resource sharing in advancing scientific research today, particularly during any financial hardships of war, recessions, and depressions. Their work serves as a poignant reminder of the historical context in which modern astronomy has evolved and the enduring value of perseverance and innovation in the scientific community. If anything, astronomers excel in this aspect, this attitude that we have. This story encapsulates the essence of Innes and Cook's collaboration, emphasizing the significance of their work and highlighting their partnership's enduring legacy in the history of astronomy. Thank you.
Keeping time. Any questions?
No, I can run away.
Okay, let's thank Ian again.
Thank you.
And now we come to our last talk by Ian Glass, but co-authored with Jennifer Whittle and Chris Sturken, but presented by Ian on commentaries on tangible and intangible cultural heritage, not astronomical heritage, at the Cape.
This is a sort of last minute assembly of ideas.
I could have talked about a lot of things. One of the problems we faced in terms of heritage at the observatory was that any effort spent on preservation and looking at old instruments and saving things was regarded as a diversion from the serious purpose of the observatory, which was to do astrophysics. So it was always very difficult to get money to do anything, and even to get workshops to spend time on things and so on. This is a plan of the campus. You enter at the bottom end, and we have a number of domes that are labeled going from the bottom up. Astrographic, 6-inch. We have small building of archives. We have a visitor center that's just sort of maturing now. We have an H alpha telescope, and the main building, of course, is the one that dates from 1825 to 1828. And we have the classical things around, and there's an 1849 dome, and technical building is one of the biggest modern additions, and that was built about 1987. And that's where new equipment is made for Sutherland and things. Some of the unlabeled buildings are houses. There were quite a few people living on the site, not so many now, but the houses are still occupied. Some of them are turned into offices, in fact. This is a picture of our library. It looks very nice there, but the efforts of the digital librarians has actually ruined the old library, and it's almost impossible to find anything now. Some of the books are even stored in very inappropriate places, getting damp, and it's really a disgrace, actually. I was going to show you some pictures of it, but then I thought I might get into trouble for doing that. But you see, this part of the library was the woodwork dates from Gill's time, and Gill was by far the most systematic and careful of the HM astronomers. He actually was very keen to preserve archives, and all the stuff, all the books and letters were bound into books and things, and they're very well preserved, the ones that are still around. Some of it was sent to Cambridge University, well, Greenwich Observatory and then Cambridge University Library. So we still have a fair chunk of his correspondence here on particular things, not so much the astronomical side, but instrumentation, photography, all kinds of local interest things. So this is the Astronomical Museum. I mentioned that technical building was built in 1987, and that freed up some other buildings. So the top left picture shows what this room looked like when it was built. It was an astrophysical laboratory, the main idea being to take spectra of earthly substances to see how they compared to what they were finding with spectrographs on the telescope. Underneath it is the laboratory as it looked when I came here. I used it as an infrared laboratory for about 15 years. And then we moved the infrared laboratory across to the technical building. So that made this building free. And although the director was very reluctant to spend any money on it, we managed to set up the room as a museum and put lighting in some of the cupboards that had been laboratory cupboards, and added bits and pieces over the years. So equipment that was lying around, you know, things in people's drawers in the corners of rooms, in basements, attics and things, we tried to pull everything together. And of course, you found that people had been taking home things as souvenirs. So I'm sure quite a lot of the chronometric watches and things disappeared over the years. And we just tried to lock up everything we could find that still existed. So you will find some quite interesting things in this museum. I think I have a detail somewhere. Yeah, just to show an example of the kind of things I put in the museum, the left big picture is actually of fairly modern things. They're detectors, stuff to do with infrared. There's a CCD in the bottom left corner, various types of image tubes, and photomultipliers and infrared detectors and stuff like that. So this is more or less the stuff that was used since the beginning of SAAO. And then on the right-hand side, at the bottom, you see one of our treasures. That's one of Herschel's mirrors that came back here. It's one of the so-called 20-foot telescope mirrors. It's, I think, about 18 inches, about sort of 18 inches diameter, whatever that is, around about 50 centimeters. And on top of that bottom one was made by Sir John Herschel, although there were 3 mirrors made for that telescope. This was the last one of the 3. Above it is a mirror made by William Herschel around about 1810. And that was, you know, he ran a telescope making business, amongst other things. And at the very top of the display are the 2 lenses I showed before. The small one is the one used for the first pictures of the comet, and the big one was used for the CPD. So one of our interests has been the archives, and it's really been incredible what we found. Here again, we scrounged around every place in the observatory, found things that were damp, things that were in limbo, and we brought everything together that we could in the archives. Now, some of the things had been already in this archive building, but we really did a kind of search of the entire place, tried to save every photographic print, every plate that was still around, and every document we could find that was still relevant. And this was at some point during the process. But you could see the categories. We have about on the bookshelf about 500 or 600 letter books and boxes of documents, mostly just catalogued in terms of general terms. Very few of them are catalogued in details. But Auki has been involved in the photographic prints, and we have scanned something like 8,900 of them. There are still others that we could probably do. And you could see what plates we have left. Most of the plates, especially the parallax plates, were destroyed. But there are still samples of plates of just about all the telescopes that we ever used. There's an enormous number of spectra taken with the McLean telescope. We have some of the mechanical drawings, and well, we found, for example, a whole bookcase full of little memo books that observers had used, like diaries that they had with them at the telescopes and so on. Includes pictures of, for example, McClear's observations of Halley's Comet. But then a lot of the stuff that came from Radcliffe Observatory is preserved by us. So just about all the Radcliffe Newtonian plates and spectroscopic plates are still here, the ones that haven't been lent and lost that way. So you see there's a tremendous amount of antique material that we've tried to do our best to preserve and catalog as far as possible. And so there's still sections that we couldn't do much about, such as the personnel records of the people who worked mainly in the 20th century, the end of the Royal Observatory, beginning of SAAO. These are the telescopes that are on the site. The left is the Leo. That's in 1957 or 58, or 55, somewhere around there. There was an international project to monitor the sun in H alpha, and we were one of the sites for that. So it took automatic photographs every 2 minutes on film. And so the telescope was just set up in the morning by one of the lady computers and let run all day. And then the McLean telescope, that's connected to the museum. And that was the big telescope, just around 1900 vintage. It has a rising floor, hydraulic floor. So it was a very modern telescope for its time. And then the 18-inch telescope started life as a mounting of a heliometer. That was Gill's main heliometer, and that it was replaced by the first reflector on site around about 1955. And that guide telescope you see is a Mertz 7-inch telescope from 1848 or 49. And on the right is our astrographic as it once looked. At the moment, it's in pieces, but we're think there's a good chance it'll be put together again and made to work even. The photoheliograph still works. It's in a dome from 1849 that runs on cannonballs. It's quite an interesting place. And then we have a 6-inch Grubb telescope. It's not in its original mount, in its original dome. It has a sliding roof observatory. And then the Gill reversible transit circle still exists. It's also in pretty bad condition. I cleaned it up a couple of years ago and removed literally buckets full of dirt and dust from it. Oh, I thought I had another one. Oh, sorry. I thought I had another slide, but it seems it wasn't included. Okay. Okay, if anything I can enlarge upon or talk about. Yeah. Come up. Yeah.
I had a question about the Carte de Ciel telescope. Is that still present?
That's the astrographic.
Oh, that is the astrographic. Okay.
It's interesting that our Carte du Ciel plates had a reso cast on them in some of the earlier plates, and then they decided that was counterproductive, that it affected the XY measurements too much. Yeah.
Is there a catalog of the Astronomical Museum or not yet? Or have you published the... Or another question, what is the oldest instrument preserved in the museum?
Yes, I have a catalog of the museum. It's mostly online at the moment, but I can give you access to it. And the oldest instrument we have is a reflective circle from before the French Revolution, made by the French instrument makers. I can't remember the names of them, but it dates. Yes, Le Noir. And so it's one of about some reasonable number of them. There are several others in museums around the world. So they made a whole series. This one was given by the king to a naval officer of the time, but it's in quite good condition.
Is in the archives correspondence letters and information that was shared during the active years of the observatory could be a very good media for reconstruct history. Correspondence letters mainly, or interchange of journals?
Well, we have the last director of the Royal Observatory, Stoy, we have an enormous amount of correspondence from him, mostly unsorted. It's alphabetized, but that's about it. And then there are certain, Gill, for example, was a prolific correspondent, and we have a lot of his correspondence, but not so much astronomical material, although there are sort of isolated things like correspondence about comets, for example, from Gill's period. But older than Gill, we have very little, unfortunately. Just sporadic things that somehow got left behind. Most of the documents were sent when it changed from Royal Observatory to SAAO. A lot of the stuff was sent back to the Royal Greenwich Observatory, which closed down, and so a lot of that material was sent to Cambridge University Library. So there's a category called RGO 15, which is hundreds of volumes of material related to the Royal Observatory Cape. So it is accessible. Some of it's even online, but not all of it by any means.
Okay, well, that's all the questions.
Okay, sure.
Do you want me to go ahead?
Yeah, go ahead.
Okay.
Put on my.
So Chris Durkin asked me to say a few words to conclude this whole FM6 on history of astronomy in South Africa. And I think we've had 6 extraordinary sessions. And what really impressed me was the great range and variety of astronomy done in this country in South Africa. And I think I can say that, well, I think you will agree that for about 200 years, from 1750 to 1950, South Africa was the preeminent country in the Southern Hemisphere for astronomy. So it dominated over Argentina, over Australia, and certainly over Chile as well. And if you wanted to observe the Southern Hemisphere, astronomers came here to South Africa. So for 2 centuries, South Africa dominated. And that domination was partly due to extraordinary people who worked here. We've heard about many of those: Lacaille, Fallows, Henderson, Maclear, Gill, John Herschel, Innes, Finson, Roberts, and quite a few more. So they were fantastic people who worked in South Africa. I think it's very significant that the Royal Observatory at the Cape was founded in 1820, more than 200 years ago, and it's the oldest scientific institution in the whole of Africa and still going strong. But it wasn't certainly the only observatory in South Africa. We've heard about many others during this focus meeting. Lacaille's Observatory, the Union, later Republic Observatory, the Boyden Observatory, John Herschel's observatory at Feldhausen, the Radcliffe Observatory, the Leiden Southern Station, and the Lamont Hussey Observatory, which we've just heard about. So they are all operating at various times in this country. So there's a fantastic heritage of astronomical activities that took place in South Africa. And I think I can say that South African astronomy now with the SALT and SKA and amongst them is stronger than ever, even though most of you would agree that South Africa is no longer the preeminent country in the Southern Hemisphere for astronomy, even though South Africa's astronomy is still amazingly strong. Probably everyone would agree with me that Chile has overtaken South Africa, but that doesn't really matter. The history of this country in astronomy is fantastic, and that's what we've celebrated. And that's why the IAU, by the way, agreed to have a focus meeting devoted just to this one country. There was some pressure that it should be a focus meeting on the history of astronomy in Africa. That's a very different story. Though we've heard a little bit about Namibia, South Africa is where it was all happening for 200 years. So for me, that's amazing, and I hope you found it amazing too. Now, I'd like to thank Chris, because this focus meeting was only possible because of your efforts, Chris. You did 99% of the work, I think, and your scientific organizing committee did 1%, if even that. What's that? You got some slides to show. And Chris asked me to say that we're going to publish some proceedings from this focus meeting, and the IU have granted us 50 pages in a volume of 12 different focus meetings, this being just one. So we get 50 pages, and for 24 talks, was it? 20. So 50 pages is not much, but it will be published in due course by Cambridge University Press, I guess. And so Chris is going to communicate with all the presenters about what material we require. And Chris asked me to help him edit that 50-page contribution to this. So Chris, do you want to say a few more words about that?
Thank you, John. Actually, the last talk of the day was cancelled, and this is why we have organized a discussion on heritage shared by Jan Glass and myself. So it's a very short story here. First, I want to talk about the survey beacons in South Africa. There are several survey beacons, and you have here the southernmost part near Buffelsfontein. There is this beacon. It's a national heritage monument in South Africa. And another one is the one I have shown in my slide, and this is the Maclear beacon. It's also, again, it's protected really. The first one is fenced. This one is not, because nobody comes there just like this in the night. This is the plaque there. And this is a third possibility. And Jennifer Whittle and her colleague Bell have suggested that we would try to make this also a national heritage monument. And the thing I want to do with Commission C3 in a couple of weeks that rest me, and then it will be taken over by Sarah, is to suggest that the Commission endorses this proposal, of which we are not part, but we would endorse it, and that may help pushing it. This is about tangible heritage. There is also heritage that is important. Okay, here. And this is intangible. And here I think about names of minor planets. And you remember in my talk about the Dutch station, observing station, there was a man who died young in Utrecht. Van Gent was the name, and he started a tradition. He discovered minor planets. He started a tradition to give names to colleagues and also to their wives. So there are several South African minor planet names, but since he passed away young and he did not continue this, the tradition was stopped. Now, I don't know if There are people in the room who have known Henri de Bourgogne from Brussels, and he was a minor planet chaser. He discovered several, and actually has a list of about several hundred discoveries. And shortly before he passed away, I knew him quite well because we were quite often together at the observatory in Chile. And well, when you both work all the time, you don't have time to talk a lot, but you understand each other well. And several months before he passed away, he phoned me and he said, well, I would like to talk to you. And he proposed, he said, I would like to name some of my planets to people, but not to the big shots, not to those people who are everywhere in the center of the attention. I want to do this to people who are a little bit in the background and do very good work without which these people would not probably be that well known. So he wished to honor the invisibles, actually. And he said to me, well, look, I'm not very good anymore at writing letters. He was still writing letters by hand and so on. Can you do that? And he wanted also that some of his mathematics professors were nominated. So I started to do that. And before I could really give a list to him, he passed away. Yes. So I continued this, and one of the very first minor planets that I nominated was Captain Robert Fitzroy. Captain Robert Fitzroy, who was the captain of the Beagle, who came here to Cape Town, and without whom Darwin would be less Darwin than he finally became. Also, Fitzroy participated in observations and in discussions. Now, the idea that I had is that because behind every famous man, or besides, or before, there is a strong woman, I started the idea to nominate a few females. Yes. And the first one, which has been accepted, is Marianne Hervey. This is Mrs. Fallows, yes, because of the work she did, and also because she saved his data and brought them to archives, data which we still can use today. This is phenomenal, yes. So this is the website where you can view, and this is the position here. That's the minor planet Marianne Hervey. The time of the picture is tomorrow morning at 00 hours UT, and tomorrow is Women's Day in South Africa. So it's very fitting to do this and to make this arrangement for this meeting. The second one is Mary Pierce, which I have selected. And she was the spouse of Maclear. They also work together all the time. They are both buried in the grounds of the Royal Observatory. If you go there, you will see their grave. They are together, and this is a similar diagram. And the third is somebody whom I personally would thank a lot, but never met. And this is Johanna Terlinden. And Johanna Terlinden is Mrs. Walraven. So very few people know what she has done in the development of the telescope and also in the development of this photometric system where he was so famous of. So this is the situation, and there can be more. Others, for example, I would like to suggest is here the one who was mentioned by Virginia Trimble with his son Okoye. And I will propose to the Commission C3 that they consider, but of course we need the agreement from Sarah, that they consider becoming a clearinghouse for working on this and getting longer list of people to honor with this possibility. Thank you. About what John said.
So I will be winding up too early. My apologies.
No problem. What you said about the 99.5%, I don't know what your error margin is, but it's not totally correct because I had a fabulous team. The scientific organizing committee, you know how it goes, yes? You have a committee, people are happy, sorry, people are happy to join a committee, and then all at once you see that some people don't react, others are a bit slow, and so on. At the core of the scientific committee, who always answered to all emails and suggested things, that core is a set of half a dozen chairmen and women of this meeting, minus one who couldn't be here, but she was very encouraging all the time. And in the Virginia Trimble way, sometimes I had to think twice what she wanted to say, but it was always very good, very supportive. So the team did a lot. Without the team, I wouldn't have succeeded, frankly.
Well, Chris was the team leader anyway, so.
Okay.
I've already wound up the focus meeting, so thank you for your final. Now we can all go.